Not NixCon. Yeah. So, how loud can I go? Not that loud. Is this loud enough? Yeah? Yeah, I mean, hello? Can everybody hear me? Like to the back as well? Or not? Can you hear me here? Even when there's talking going on? Even when I whisper? A little bit less, yeah. So I have to articulate stuff. Okay, nice. The gate is working. Yay. Is it too loud for the stream? If you can still hear me, that is of course. Because we are having a little bit of auditorial problems. Not auditorial, just audio problems. So if you can hear me fine, please let me know.
Mic test, mic test, mic test. We're doing some mic tests. Here's a mic test. Do you hear me well at the back? Can you turn on my mic? No? It should be a bit louder, Brian. No, don't hear me well at the back.
1, 2, 1, 2,
Wait. I can hear yourself through this. I think so.
Lip sync.
Do you still hear me? Yeah. Should be louder for the back. Alex, I'm going to say yes, and Julian is louder. Okay. So Alexandra is saying louder. Julian is saying louder. Does it still need to be louder? Louder. Do you hear me well? Julian, can you say something like that if it's wrong? Louder, they say. Louder, louder. That's louder. Louder, louder. Louder? Good. You can put it right now. No, it's not. Yeah, sorry. Alexandra, do you hear me well? Do you hear me well?
Do
I think I was heard at the back right now.
So, Ryan, can you talk up just a little bit?
Yeah, I can talk right now.
Why are you so much quieter than I am?
I can talk.
Describe how to ride a flake when you're on stage. We'll see how.
1, 2, 1, 2. I guess everyone has to be quiet, and they will all heard about us.
Us.
That doesn't help. Can you help me?
Yeah. Am I turned on? 1, 2, 3.
Let's try again. Do you hear me well at the back? Again? Yeah? Can you hear me well? Oh, okay. Seems to be good now, Red.
1, 2.
Do you have the list?
Yeah. 1, 2, 1, 2.
I didn't change
Can you hear me
anything
okay?
though, so
Or I'm not on.
sure what changed.
You're on? I'm on. 1, 2, 3. Am I good? Should I try my Shakira voice? One, two, three. Better? Yeah, Gabriel? Okay. All right, let's get seated. Start off the day. We promised 9 sharp and we delivered. It's 9:10. Giovanni, can you please sit down? I don't think they can hear me. Rock, can you take Giovanni to the seat?
Your friend is asked to sit down right now.
We are requesting.
Otherwise, content at your shopping store are not going to be merged in Nix.
All right, let's get started. Second day of NixCon. As you can see, probably our 30% of us party too hard. I don't know how that's interpreted, but okay. So again, welcome to the second day of NixCon. After you're all here, but we have a huge list of even, just amazing talks throughout the day. We're gonna have
No wait bench.
Very cool. And then we're gonna have at the end of the day the hiring happy hour. So you might see the closing ceremony and then hiring happy hour. That's good. Hiring happy hour, then closing ceremony. There is no alcohol in the hiring happy hour. Be happy. And later have the alcohol. What else is there?
We have the preparation for the tear down. So basically, we need to take all these chairs we rented and we need to give them back to our suppliers. So we're going to need a lot of hands for that. We're going to need a lot of volunteers. So it would be really cool of you if you could stay like from 6 p.m. to 8 p.m. to help us tidying, clean up the venue and provide everything to our supplier so that we can focus on the last day of the conference, which is hacking, right? So we're going to do 20 people, more or less, for that. And that would be really amazing. Other than this...
Actually, before we continue the next thing, can we get just a quick show of hands and who's closed on it, so I know if I need to, like, after this talk, come hassle people on this? Who can kind of stay and break down things? Okay.
You guys are amazing. Thank you a lot. I'm going to review all your periods on which pages if you want. Also, we have a lot of trash. We're generating a lot of trash. That's normal. If you could help with us to sort your trash, glass with glass, cans in some sort of crates. Don't throw anything like in the same bin. That will help us a lot, and we might need some volunteers to help us to take out the trash to a place where we can sort the things. That would be good. We will pay you to do that. Don't worry. Other than this, the hack coming tomorrow, right? So please check out the board to see if any idea interests you. Please add ideas. I think at the end we're going to copy all these ideas on the Matrix channel so that everyone can know what is going to happen. Special highlights. Tomorrow is going to be a special event during the hack day, organized by Sylvan Mosberger. Let me know if I heard your name or something. It's going to be a QA Nix lecture where everyone can come during 1 hour and ask any beginner question about Nix and NixOS, and it's going to be, I think, really amazing. Trust me. So I encourage you to see on the schedule. It's on the schedule. It's going to be 2 p.m. tomorrow in one of the breakout rooms, and there can only be maybe 35, 40 people. So please show your interest if you really want to go, and if you are more than 40, I have to find a solution. And I think we're done.
One more quick thing. Just in general, questions, topics, threads. I know we have the NixCon channel, but it's like, right, kind of blurs past everyone and you miss a lot of messages. I'll open another discourse post today, NixCon Day 2. If you're watching a lightning talk, a regular talk, or just want to ask Teofan a question, just feel free to ask it there. I'm just, sorry, Teofan. I don't know why I'm picking on you today. Just add it in the thread. All the speakers will be on that thread. They'll be able to answer and just, you know, have the async conversations as well. So other than that, have a good NixCon Day 2. Yesterday was awesome. Today will be awesomer. We're at the same level, but thank you guys.
Enjoy the conference. Thank you very much for coming.
Thank you, Ron and Ryan. So, can anybody still hear me like this? So, thank you again, Ron and Ryan, for letting me start 5 minutes late, or 10 minutes late, rather. Can I have the lapel microphones back? Because Linus will need one. Thank you. So yeah, again, thank you all for being here again for a second awesome day. Are we excited? It's a little bit less than yesterday, right? Yesterday in the evening, everybody's like, woo, we were less people, but that doesn't matter. So again, please, right? Are we excited? That's getting there. By the end of the evening, we'll be more, we'll be louder, it'll be nicer. So, projector probably turn off. So yeah, the first talk given by, honestly, I think one of the best names that you have, by Linus Heckerman about getting Nix to run pretty much everywhere, right? Yes, okay. Have you unmuted yourself? Okay.
Good morning.
I have to unmute it there still.
Okay.
But good luck already. So please give a round of applause for Linus again.
Testing, 1, 2, 3. Good morning, everybody. I gather everyone's awake from the reaction to Brian's intro there. I'm Linus. I discovered Nix and NixOS for myself in 2016 and quickly became convinced that that's the way I want to do all my computing. I joined the ranks of Nix packages contributors. Hang on, something's wrong here. Sorry. There we go. I joined the ranks of Nix packages contributors and have been following the call of Nix in my career since graduating from university. Along the way, I've managed 2 NixOS releases, and I've been on the RFC steering committee since 2021. We're looking for new members, by the way, so get in touch if you're interested in helping. I work at Determinate Systems, where we're working on making Nix the best choice for working together. So, what's NixOS? NixOS is an operating system based on the Nix package manager and Linux. Linux is an operating system kernel, which means it runs on the hardware and mediates access to that hardware by the user space, providing abstractions to allow applications and services to care less about what exact hardware they're running on, and allocating resources to allow multiple processes to run at once. I'm going to talk about how we get from a bootloader to a complete operating system, then compare how traditional Linux distros and NixOS fit the pieces together, and then showcase some of the possibilities that NixOS puts within easy reach. When did that happen? Is that better? Tell me if that happens again. When you power on your computer, a number of things happen. The first that we're interested in is the bootloader. It's what's responsible for loading both Linux itself and for giving it the startup parameters needed for getting the user space up and running. Some widespread bootloaders include grub and systemd boot, and especially in the non-desktop world, uboot. These startup parameters are usually the command line and the initramfs. The command line tells the kernel some configuration that applies before the user space can take care of that, such as logging behavior, how to respond to crashes, or what user space to actually start. And the initramfs is a bit more interesting for our purposes. The initramfs, which is an abbreviation of initial RAM file system, is where user space starts. It's a tree of files, traditionally stored as a disk image. Nowadays, usually it's an archive. It contains everything that the system needs to boot. The kernel will run a program, often just called init, from the initramfs as the first user space process. The role of that process is to get everything ready for the real system. Modern desktop kernels are usually modular, meaning that they don't include drivers for every piece of hardware they support, instead loading them as modules later on. This makes kernels significantly smaller and faster to load, but that also means that drivers like storage for things like storage devices and file systems, which you need to be able to start the actual system, aren't included in the kernel itself. That's why it's part of the initramfs's job to include and load these drivers. Other things it does is, if applicable, for example, asking the user for encryption keys, or setting up networking in case the user wants to enter the encryption keys via the network, or the root file system is on the network, things like that. Once it's done those things, it will usually mount the root file system and pass control on to the next init, that of the real system. So the init in a root file system then starts up the rest of the user space. On a typical desktop system, this includes services like clock synchronization and network management. One of the services is also the login service, which provides login prompts both on the text consoles and the display manager, which provides graphical login. So let's look at how a traditional distro like Debian fits these pieces together. The kernel is a package managed by the system package manager. It includes both the kernel image itself, which is what the bootloader loads, and the modules it needs to support a wide range of hardware. The package includes post-installation scripts, which the other parts of the boot chain can hook into in order to reconfigure themselves once you get a new kernel. The initramfs tools package handles generation of the initramfs. It installs a kernel post-installation hook so that whenever you get a new kernel, it'll generate a new initramfs by collecting some information from the system, from config files and such. Config files like etcfs tab, which defines the file systems that are supposed to be mounted, etc crypt tab, which defines encrypted file systems, things like that. It then copies the contents. It puts all these pieces into a temporary directory. So these pieces being kernel modules, init scripts, the dependencies of the init scripts, and the configuration files for them into a temporary directory and generates an archive from that temporary directory, which is the initramfs. The bootloader is also a package managed by the system package manager. The package contains both the bootloader itself and, again, scripts for installing it to the hard drive and for generating its configuration. The installation scripts are usually only run when the bootloader is installed or upgraded, and the configuration scripts, those define the actual boot options, so the kernel command line initramfs combinations. So they run every time. They also hook into the kernel post-installation scripts and run every time you install a new kernel. And both the initramfs tools and the bootloader can be configured via a multitude of files in /etc. Of course, you're all here for Nix and NixOS, so let's have a look at how NixOS does it. One key concept of NixOS is the system package, or top level. The entire system configuration is built into a single package, which depends on everything the system needs. I've taken the liberty of illustrating this part visually. So, of course, the kernel is going to be a dependency of the system package. I think someone's seen this video before. The command line is part of the config, so into the system package it goes. The initramfs, we can build that in Nix into the system package. Now the bootloader, we have a slight problem here. The system can only have one bootloader installed at a time. Let me hand wave away the slight technical inaccuracy of that statement. But we still want to be able to install it. So we have an installation script. And where do we put that? In the system package. As for the bootloader config, we also have a problem there. We only have one configuration for the bootloader. But we do want to have the ability to have multiple generations of the NixOS system, right? That's what we love about NixOS. But we also don't want our new system to depend on previous systems. I'll get some people. So let's not include the bootloader config as part of the system package. But we do need to generate a bootloader config at some point. So we have a generator, and I think you can guess where we put that. So let's have a look at a real system package. In a running NixOS system, there's a symlink /run/current system, which points to the system package that's currently active. This package contains, amongst other things, the following: a symlink to the kernel image itself. Often the bootloader can't load it directly from the root file system and needs it copied to a boot partition instead. This symlink makes that easy. A text file containing the kernel command line. I don't have the whole one because it's quite long. A symlink to the initramfs. NixOS uses a historic but now technically inaccurate name, initrd. Like the kernel, this might have to be copied to a boot partition. A text file containing the NixOS version string. This is nice for decorative purposes. It's good to have the version in your boot entry name. The init script, this is the root file system one, which the initramfs hands over to. It does a little setup before starting systemd, NixOS's service manager, because systemd won't start successfully if its config isn't in place yet. and the switch to configuration script, which takes some steps to apply a NixOS configuration. This is what NixOS rebuild does under the hood, and what exactly it does depends a bit on the argument given. If you give it switch or test, it will measure the current state of the system and determine what needs to be done to move to the configuration defined by the system package. It then takes those steps in order to activate the system. Another thing the switch action does, which is also performed by the boot action, is to run the bootloader configuration script we talked about earlier, which looks at other generations of the system as well and generates bootloader config for all of them by looking at the files that are part of that system. And the switch and boot actions may also install the bootloader, but that only happens when a particular environment variable is set or an argument is passed, which NixOS install does so that you have a bootloader, but it doesn't usually happen. So that concludes our whirlwind tour of how a classic desktop NixOS installation boots. But what sets NixOS apart, besides, of course, declarative configuration, parallel installation of multiple systems, parallel installation of multiple versions of the same package, safe per-user package management, rollbacks, easy and fearless patching, reproducibility, and all that, is its flexibility. So what if, for example, we were to just put the entire NixOS system in an init ramfs? The module that implements this is called netboot, because that is what it was originally implemented for. Instead of generating an init ramfs, which has the necessary bits and bobs to mount a local file system, it generates an init ramfs, which contains the entire system and all of its dependencies. That's an easy way to boot the whole system from RAM, and is really useful for netboot, where a bootloader like iPXE will download the kernel and init ramfs via the network, then boot it without having to touch any local persistent storage. It's quite heavy on RAM usage. Since the system and all its dependencies are loaded into RAM, the system on my laptop, for example, is 5.4 gigabytes in size, so I might not want to have it in RAM at all times. Of course, while the system doesn't need local persistent storage, it can still make use of it. For example, a swap partition can be used to allow swapping out unused RAM, such as all the software you're not running right now, and make physical memory available for things that actually need it. Or you can use the init ramfs as an installer. You can use it to install NixOS to the local storage. That can be really useful if you want to provision a whole fleet of desktop machines or servers, or if using a USB stick installer is just not enough fun. I've been in both situations. As an aside, nowadays the netboot image does not embed the entire system directly into the init ramfs. Instead, it embeds a squashfs image, which can compress the file system a bit more efficiently than the CPIO archive, and allows keeping it compressed in RAM, unlike the init ramfs, which is unpacked during boot. So that's a bit more efficient, but still has the problem of using up all the RAM as long as the system is loaded. There's also an open source project by Determinate Systems called Nix netboot serve. Instead of constructing one big init ramfs image ahead of time within a Nix derivation, it puts them together from the constituent store paths on demand. The end result is very similar, but allows much speedier iteration, since each store path is cached separately and only the parts that change need to be recompressed. So netboot is great and all, but why limit yourself to booting it via iPXE? Linux has a nifty little piece of functionality that allows it to act as a bootloader itself, called kexec. The netboot image can be loaded via kexec without any further adjustments. The most common use case I've seen for this is bootstrapping NixOS support from other Linux distributions on VPS providers that don't allow supplying a custom disk image or booting from custom ISOs. You build your netboot image on your workstation, async it to your Ubuntu machine, call kexec with the appropriate parameters, and hey presto, you have a NixOS system from which you can format the disk and use NixOS install to install the operating system you actually want. I've also used it in the past instead of an ISO installer to make file system changes which weren't possible in a running system which had the file systems mounted, which saves you the effort of formatting a USB stick and having to boot into that. But another trick with similar applications is switch root. So let's go back to our normal init ramfs. The init script in there uses the pivot root system call to tell the kernel to swap some mount points around, and that allows replacing the current root file system with the new one. But again, why limit ourselves? We can't only do that from an init ramfs. Systemd exposes a command that allows shutting down the running user space, but instead of powering off the machine or rebooting, this command will do exactly what the init ramfs did. I'm sure it was originally intended for systems where systemd is used in the init ramfs, but why shouldn't we use it outside the init ramfs as well, right? So for example, you can build a NixOS system and copy it to a tempfs, then switch root into that tempfs and boot into NixOS from another distribution without leaving any traces besides shell history behind. I've also used it to put an Ubuntu installation on my laptop without letting it touch the bootloader, without having to repartition the disk, and without having to mess around to get ZFS support in Ubuntu, since I was still running NixOS's kernel. The reuse of the kernel is what makes this approach applicable in some scenarios where kexec is infeasible, such as if the kernel you're using doesn't implement it, or if it doesn't work on the platform that you're working on. Your mileage may vary for anything that relies on the kernel here, since the system you're switching into is very likely to have an incompatible set of kernel modules, which won't be loadable. This means that hot plugging devices whose drivers weren't already loaded or which need firmware files not provided by the target system will fail, for instance. But it's a bit more versatile than anything purely init ramfs based, since it can use real file systems. As mentioned, I put that Ubuntu on a ZFS dataset. So let's move on to something you're probably more familiar with. Custom ISOs. I'm sure this is one of the use cases many of you have used before. NixOS's own installer images are built from full NixOS configurations. Like the netboot module, the ISO image copies the system package into a squashfs. It then takes the squashfs, the kernel of specialized init ramfs, a bootloader with appropriate config, and the necessary bits and bobs for both BIOS and UEFI to recognize it as bootable, and bundles them together into an ISO image, which you can write to a USB stick, or if you're feeling nostalgic, to optical media. Single-board computers often boot from SD cards. NixOS has the tooling for building SD images as well, since that's the workflow users coming from other distributions have come to expect. Generating non-installer images is a bit of an anti-pattern for a number of reasons. Hit me up later if you want to hear me rant about it, but it can be very useful nonetheless. So if you're not working with hardware you can touch, VM images can be very handy. You can generate a base image pre-configured with your SSH keys and standard tools to enable quickly spinning up new VMs. Just clone the image and boot the image, then deploy your configuration. Or you can configure the services you want the VM to provide, build an image from there, and boot without any further configuration or deployment steps. So here I'm going to shill from my employer a bit more. Determinate Systems has been working on a tool called Ephemera, which, given a NixOS configuration, instead of building a disk image inside a Nix derivation, builds a NixOS system package into a disk image outside the sandbox. This allows caching some more parts, similarly to how Nix netboot serve does it, and enables parallelizing it a bit more, and brings image build times to only a few seconds. The images are stateless, so it's expected that if the configuration needs to be altered, the image will be replaced. But after all, the images are really cheap to build. Combined with the AWS snapshot upload tool ColdSnap, this allows going from a NixOS configuration to an AMI, faster than any other toolset for building AMIs known to us. We're pretty proud of that. But Ephemera is by no means limited to AWS. It should be usable on any cloud provider that allows uploading custom disk images, and we've also tested it on local QEMU VMs and on hardware. We're very excited about it, but it's currently still in its early stages, and we haven't published it currently. Feel free to ask us if you're interested. Even with ephemera, working with disk images isn't always the most convenient way. Since the NixOS system package contains everything that you need to boot it, it's also pretty easy to run a NixOS VM on a host that has Nix installed without any image generation. QEMU has a built-in file sharing implementation that allows sharing the host's Nix store to the guest's read-only and booting directly from that file share. NixOS allows generating scripts which take care of the tedious parts of building the QEMU commands for this. This is really great for This is really great for testing configuration changes without deploying them to a persistent staging system or without building images. I use these VMs to try out Nix packages changes for reviews, to test out software I'm not yet sure I want to use, and I've also experimented with using them for fully scripted NixOS installs onto physical media, but I don't trust myself to touch only the relevant physical media and not accidentally wipe my laptop in the process, so I do it in a VM. And being able to shut the VM down afterwards makes cleanup much simpler, so I don't have to unmount the file systems, close crypt setup volumes, etc. manually. However, this VM infrastructure is also used for what I believe is one of NixOS's wildest features, the full system VM-based integration testing. It runs QEMU VMs, or even networks of them, inside Nix builds to verify a huge range of functionality provided by NixOS. We have tests for a wide variety of installation setups, which boot the ISO to install on various combinations of LVM and LUX, as well as various file systems. The NixOS channels won't update if these tests are broken, which allows us to make changes to the installers and file system support with confidence that we won't break it for everyone, or at least we'll usually find out before being confronted with disgruntled users. We also have tests for many NixOS modules. The Nextcloud tests ensure that all 3 supported Nextcloud versions work with 4 different database configurations, so we have 12 different configurations which are tested. Our networking tests ensure that a client can talk to an external network through a router with NAT, also an NixOS VM, and that our firewall works correctly. We even have an open arena test, which pulls up a network of VMs, runs a game server on one, and bot clients on the others, and takes screenshots of the action. And all of this is within the Nix sandbox. So these tests are completely independent of online services and won't break from one day to the next due to external circumstances. NixOS makes heavy use of them, but I'm sure there are many use cases outside Nix packages that would be well served by the NixOS test infrastructure. Now, NixOS isn't suitable for all machines that can run Linux, because some of them are don't have enough RAM or enough storage. But that doesn't mean we can't give them the Nix treatment. Thanks to Nix packages' cross-compilation support and some kernel patches I cribbed from OpenWRT, I run a small Linux system built with Nix on my Wi-Fi access point. It's a little kernel in init ramfs, which I currently boot via the network. And the init is just a shell script that starts the necessary bits to supply network connectivity and drop there for SSH access. But I haven't really needed that SSH access since setting it up, because it just works. The biggest problem I had with it was when I wanted to take this picture, I accidentally unplugged it, and then my Wi-Fi was gone. But yeah, Daniel Barlow's gone a bit further with the concept, and his work predates mine and inspired it a bit as well. And he wrote NixWRT, though I gather he's currently rewriting it as Liminix, which supports a wider range of devices and more use cases, including router setups and things like that. And in principle, it can run on anything that OpenWRT runs on. Might need some extra work, though, for some platforms. Samuel DR also has some interesting projects going on around building embedded Linux systems with Nix. I believe he originally started this in order to create this Toboot installer, which he builds with Nix, but isn't based on NixOS. But he's been working on how to generalize that into a more universally applicable embedded Linux system build framework. Not dissimilar from Buildroot, for example, in use cases, I believe, called Sealan. It's still in its early stages, but he's got both the Toboot installer building with it, and he's built operating systems for a variety of obscure emulation consoles using it. So I think there's a lot of space to be explored there, and I'm looking forward to what Samuel, DR, Dan, and the rest of the community will dream up over the next few years. So let's talk about NetBoot again. I'm going to start talking about things that I haven't done before, and that might not have generic practical implementations yet, so take these with a grain of salt. Serving a full system init RAMFS is an easy way to get your NixOS on a machine, providing it has enough RAM and/or swap. But it's certainly not the most efficient, because you're downloading the whole system before you can even start booting properly. Classical NetBoot setups only serve a small init RAMFS containing the network drivers and configuration for mounting a network file system as the root. This is, of course, also possible with NixOS. Certain properties of Nix make it possible to do this much more efficiently as well. For instance, the Nix store is practically append-only. Once a path is there, it'll only change in very unusual circumstances, and even then it should be functionally equivalent. This means that store paths can be cached by clients indefinitely. This would combine the flexibility and central manageability of classic NetBoot setups with the performance of a local installation. There's a lot of room for creativity here. Since store paths are immutable and can be signed, they can be obtained safely from untrusted sources. This makes peer-to-peer distribution possible, meaning that the NetBoot server can be provisioned far more economically without impacting performance. Again, in theory, I haven't done this in practice. So, a lot of operating systems can boot in these ways. What I think is fairly unique to NixOS is that because everything is pulled together from a declarative config into an immutable package, it's much easier to do all these things. You can take the NixOS configuration running on your laptop, factor out any bits that are specific to the hardware, and then get your laptop's configuration running in any of these environments in a matter of minutes. You can build installer images with pre-configured Wi-Fi and SSH so that you can install on hardware remotely. You can put SuperTuxCart and OpenArena in for geeky open source LAN parties. I generated NixOS images with a patched version of another open source game a couple of years ago to allow my Windows-using friends to play with some of the bugs fixed. The possibilities are endless. The NixOS Generators project pulls several of these options together into one convenient command, and it's a great way to get started playing with some of these. So you can probably tell I'm quite excited about all this. If you're excited about it too, I'd love to hear if you implement the peer-to-peer super cached NixOS NetBoot setup, or if you come up with and implement some even more exotic ideas. Find me at the hackathon, or feel free to drop me a message on Matrix. Thank you. And and I've got links to a number of the things I've mentioned up on there. Is there time for questions?
Yeah,
Happy to take any.
Of course, there's no sound. Here we go again. There's probably no sound because I'm not sending anything to there. Do people want to yell for questions? Yeah.
Go ahead, and
Yes,
I'll
mic
repeat
is
the
picking
question
up
so
signal,
the
but I'm not sending
people
anything.
can
So
Still speak into the mic, yell loud enough for lines to hear.
So thank you for the great talk. I'm wondering how far can we go with something with Cryo, which is checkpoint and restore, in order to make like live migration of actual NixOS machine easy. Like what kind of use case can this unlock in terms of everything we does?
Was the stream able to hear that, or should I repeat the question? Okay, so Ryan asked if what Cryo, checkpoint and restoring user space, might enable with this. That's exactly one of the exotic use cases I was hoping to hear about, which I didn't think about myself. It sounds really cool. Yeah, that sounds exciting, and I don't really know.
Thank you for your answer. I think there is no question.
Okay.
Oh, yes, sir.
Oh, what?
So it's not really a question, but I think it should be mentioned that the NixOS tests are even faster by now because of you, because you fixed the 9p file driver. file system driver, and so the NixOS tests are even greater, and I think that should be mentioned.
Thank you. I considered putting some shameless self-promotion in there, but decided not to. I have a blog post on that if anyone's interested. You can find my blog right there. Cool. I think that's it. Oh, no. Can you do it?
Thank you again, Linus. Great talk. Can Leo also, Leo?
Just here.
Ah, he's there. Okay, cool.
We need to use the backup laptop.
I have no idea what, okay, there.
Yes. No worries, no worries.
If Richard could also already come to the mixing console in a second.
Quick reminder of the rule of yesterday. Please do not stay too long at the back for between each talk. Otherwise, breaks are going to be shorter.
It does not seem to. Oh, okay. Yes. Okay.
So up next we have Leo going to talk about a very exciting project called NixCon Container. So good luck, Leo, and give him a big round of applause, please.
Hi. Hi. Can you hear me well? Yeah. Yes. Okay. It looks nice. Okay, I'm Leo. It's a pleasure for me to be here. I have been a Nix packages contributor since several years now. I think since 2015 or something like this. I'm currently working for Gandhi, but I'm here to talk about a side project I started working on several months ago now, which is named NixCon Container. The talk is divided into two main parts. The first part is about, I will provide a brief history about function in Nix packages to build container image. And then in the second part, I will talk about the NixCon Container project itself. But first of all, what is a container image? So the goal here is just to provide a brief overview about what a container image is and not go into all detail. So a container image is basically composed by three types of artifacts, layers, a configuration file, and a manifest file. A layer is basically a tarball that contains a root file system. So here we can say that we have the hello store path. So we have the hello binary and some shared directory, etc. Then this file system is tarred. And an important thing to note is that layer in a container image is a content addressable artifact. This means that the name of the artifact is based on its content. So, for instance, to generate the name A820, etc., we generate the tar stream of the file system and get a checksum on this tar stream. Then we can have several layers in an image. So here there is two layers, and at runtime the container engine takes all of these layers, stacks them together, thanks to some overlay FS Linux kernel feature, and starts some binary. The second type of artifact is a configuration. It's basically a JSON file. The JSON file describes how to run a container and also some metadata. So here we have the architecture, the OS, which is Linux, and then the configuration file, the configuration itself. So this means that the container will be run with a root user. And if we start the container without any arguments, we will start the hello binary. Finally, the last type of artifact is the manifest file. And the manifest file is basically a file which points to other artifacts that make the container.
So we can see we have in this container, we have the configuration, one configuration and 2 layers. We can imagine that building this artifact with Nix is pretty easy. We have to build tarball, we have to build JSON file, and this manifest file. If you want to go into details, there is the OCI specification, which describe exactly how this stuff are built. So now let's see how to build how to build a container with Nix packages. So in the initial function is called Docker tools.buildImage. This function has been introduced in, I think, 2016 in Nix packages. We can see the Nix expression to build an image that runs a hello binary. A minimal configuration is, or a minimal expression is has to contain a name and the entry point. This function, when building this expression, the function will generate the configuration file by using this entry point, and then it generates the closure of the hello store path, and takes this closure, put it in a tarball, and it makes an image. So it's pretty easy. There are some small details, but that's not important. Once we have, and then we take all of these artifacts, we put them in a tarball, and we can submit this tarball to a container engine by using, for instance, Docker load. Or we can also use Scopeo, which is a tool to manipulate container image between container engine or registry. And in this example, so we built this image. We build this image, and we want to copy it into our local Docker daemon, and then we can run this image. Scopeo has to do basically 3 things. It first gets the digest of layers. It can then query the destination if this layer already exists or not. If they don't already exist, then it has to push it. And finally, it will push the configuration and write the manifest file. So it's pretty nice. We can benefit from the whole Nix packages ecosystem to build our container images, but we could improve this by several ways. The first improvement is in the build image function, only one layer is built, but in our Nix store, we have a lot of store paths. So maybe we could, and a container image can contain several layers. So maybe we could try to put some store paths into dedicated layers. And the objective is that if you have several images on your container engine or in your registry, then we don't have to duplicate all store paths in images. We could share layer between images. That's what has been proposed in the build layered image function. It has been introduced in, I think, 2 years later, in about 2018 by Graham. So if the API is the same, it's still we are now using the build layered image function. The expression does not have to be updated. And in this case, the function will produce now 4 layers, only 4 layers because the hello binary closure contains only 4 store paths. So yeah, it's nice, but there is some limitation. I don't know exactly what the number is. I think it's about 128, but it's the Linux kernel has some limitation about the number of overlay FS you can stack. There are also some performances issue, I guess. So if our closure contains more than 100 store paths, then we want to decide what are the store paths that we want to put in separated layer and what are the store paths we want to put together. So in this blog post, there are an interesting algorithm that try to, which contain an heuristic to decide which store paths we want to pack together. So now it's nice because we can share layer between images, but we still produce one tarball that contains all store paths each time we build an image. So for instance, if you rebuild the image, then we generate a new tarball, and the new tarball will take a lot of space in the Nix store, and it's consume also a lot of IOs. To address this issue, 2 years later, another function has been introduced, which is stream layered image. The idea here is instead of producing a tarball in our store path, we will produce a script, and the script at runtime will stream the tarball on stdout, and then we can pipe this stream to Docker load or to Scopeo. So here we have built this expression. We don't have anything to change excepting the function name. It then produces a script. We can execute the script and then pipe it to Scopeo. It's nice because now we no longer have to write the whole images in our Nix store, so it preserves a lot of disk space. It's faster in terms of IOs. But each time we want to push the image, we still have to generate the whole task stream because we want to generate checksum and stuff like this. And maybe we could improve this. That's one of the objectives of the Nix2 container project. So the Nix2 container project I had several objectives in mind. So the first one is to avoid creating archive in the Nix store, in our Nix store. But I also wanted to be able to efficiently skip already pushed layer without having to read the task stream again or build the task stream each time I want to push an image. I wanted also to explore some possibility to reuse Scopeo mechanism because Scopeo is able to manipulate image between registry. So maybe we could teach Scopeo to build or generate an image from some Nix stuff and use all its internal mechanism to really actually create the image. Another objective is I think some other project has the same needs that we have, and I'm thinking about Geeks and Bazel. Basically, they also have some kind of store path, and they want to build some images from store path. So maybe creating a tool which is Nix agnostic could be interesting. And finally, to ease the adoption of the tool, I wanted to keep a quite similar interface than the ones that we know in our Docker tools. And currently, it's hosted in my GitHub namespace. So how does it work? So basically, Nix2 container, this is a two-step process. The first step is at build time, Nix2 container builds some JSON file to describe an image, and we store this JSON file into our Nix store. And at runtime, when we want to actually create the image, we will use Scopeo, and Scopeo consumes this JSON file and actually generates the image. So now how looks like the generated JSON file? We generate two kind of file. One file to describe layers, and another file to describe the image configuration. And we can see here an example of image.layer file for the hello binary. Actually, it's not exactly the hello binary because there is only 2 store paths, while the hello closure would contain 4 store paths. Yeah, this JSON file is basically a list of layers, and a layer is described by a list of paths, and the list of paths are basically the store paths that we want to put into our layer. And there is also a digest. And the digest is, to generate this digest, we take all of these store paths, generate a task stream in memory, and compute a checksum, and write this checksum into the JSON file. The second kind of artifact is the image configuration, and it's pretty, we have the image configuration with the entry point, and then we have a layer list, and this list actually points to previously generated image layers.json file. Once we have built this file, we can then use Scopeo. We added a Nix transport. It's important to note it's not upstream yet. So we are maintaining a small patch in a Nix2 container, a small Scopeo patch in Nix2 container. And we can now provide an image configuration file to Scopeo, and we can copy this image to a Docker daemon, a Docker registry, all supported Scopeo destination. Okay, so this is basically how it works. And now I wanted to explore another use case. Sometimes we are working on an image, or we are working on a software, and the software is packaged as a container image, and we want to be able to rebuild and repush this container as fast as possible. When you are, especially in a development context. And so the idea is, could we actually manually isolate some part of the closure into dedicated layer, and this is what we will see now. So at line 6, there is we are building a glibc layer. We are using the NixCon build image. NixCon build layer function, and this function will create a layer.json file. And this JSON file, or will create a derivation that build a JSON file, and this JSON file contains the glibc closure. And now we are manually using this layer into our build image function. And this means that the build image derivation now depends on the glibc layer derivation. And we will build the image. The build image function is able to, when it will build the hello closure, it will know that a part of the closure already exists in some other layer, and then it can remove this path from the closure. So this means that this means that now we are building actually two layers file, two layer.json file, and the layer that contains the hello binary no longer have the glibc closure because it is in another layer. And the advantages of doing this manually is that we have now two derivations, and this means that at build time, if we change something in the hello binary but not in the glibc, we only have to rebuild the hello binary, the hello layer, sorry. So on the hello binary, it does not seem to be really useful, but now if you think about a Python application, you have your Python code base, you have your Python environment. Your Python environment is quite a big closure with the Python interpreter, all Python module, etc. We could now isolate our Python environment into a dedicated layer and build an image for our application. And the application code base is in a really small layer. And when we work on our Python code base, we can rebuild and repush really efficiently our image, because we don't have to build and push again the Python environment. Now a few words about the NixCon container implementation. It's basically two things. At build time, we are using a Go program that take basically a graph of store paths and some other stuff, but basically it takes a graph of store paths and generates the JSON file. So this could be used by Bazel or Geeks or some other project easily. And at runtime, the NixCon container repository exposes a Go library, and this Go library is able to consume this JSON file and produce basically task stream. This library is used at runtime by Scopeo to actually produce images. So to conclude, it's still a really young project, but it's already usable. There are several of you that are already using it. It's also used in the standard framework. They are building some dev container stuff for VS Code. I don't really know what is the purpose exactly, but they are using NixCon container. And now the next step for the project is some people would like to improve the layered algorithm, the heuristics that choose which store path we want to pack together. And the goal would be to take the store path size into account, which is currently not the case. And another big step is to upstream the Scopeo patch. And then we will have to talk with OCI community, this kind of guy. And finally, I would like to add Nix2 container into Nix packages. Yeah, that's all for me. Thanks for your attention. If you have any question.
Thank you. So are there any questions? And the microphone is quiet, but it's working at least.
Hi, is this supporting the the version 2 manifest? And if not, can it be made to do so? And if so, is that reusable for the rest of the modules?
You mean the OCI manifest?
Yes.
Yes, actually, we are not generating OCI manifest. I'm just generating a JSON file, and Scopeo is generating this manifest. So I don't really have to care about this kind of thing because it's done by Scopeo.
Hi. So if Scopeo is handling that part, do the layers also get compressed now? Because V2 supports compressed layers.
Sorry, I did not hear well.
So with V2 of the container spec, you can have compressed layers.
Yes.
You said Scopeo handles taking what you point to and then turning it into a container. So does it take those and compress them?
To be honest, I'm not sure, but I think so, because basically the Go library is generating internal Scopeo data structure, and these data structure are consumed by the Scopeo engine. So I think it is doing this.
There was one more question online about how this tool could help with like statically built, statically linked binaries.
About, sorry, what?
How it can help with statically linked binaries. So statically built.
I don't think it can be helpful. I don't think it's helpful for statically linked binary, because you don't. I think the main target is Node.js, Python stuff, because there is a runtime environment that can be shared between rebuilds and between images, which is not the case with a static binary.
Okay, thank you very much again.
You're welcome.
So next up, we have Richard going to talk a little bit in a similar vein, actually, right? Containers,
actually,
Nix,
very
Nomad.
similar.
Very similar, right?
Yeah.
You're still muted, probably.
Yeah, wait, what?
Nah, you're muted over there, so I'll be muted. But give Richard one round of applause already, please.
Okay.
Can you talk now, Richard?
Yes.
Aha, there's sound.
USB-C won't help me. I have HDMI. It's just like not cooperating right now for some reason.
We are experiencing
We're experiencing NVIDIA issues, specifically. Yeah.
We do have a backup laptop.
I swear I tested this before I left. It just worked. I plugged in the laptop and it just worked, but now it doesn't. Mm-hmm. Okay, so if anyone wants to do a talk about how NVIDIA sucks on Linux, then please do so, because it just crashed on me. So, this talk will be about squeezing efficient and small Nix containers into Nomad, so it kind of relates to what we had before. Well, I'm known as Magic Garby online and Richard Brežák in real life. I've been working as a contractor at Serocal for a year, about just, and since September, I'm a full-time bachelor student at the VU in Amsterdam. And since roughly June, after convincing them, I've been working on Nomad bring up at Serocal. So if you don't know what Nomad is, the other word for Nomad is Kubernetes. It's essentially the same thing, just by a different company, and works in a bit different way. The difference between Nomad and Kubernetes, if I had to summarize it, would be that Kubernetes, where Kubernetes uses many different types of workloads. If you want to deploy things differently, Nomad has a switch. So it's very extensible and works in a different fashion than Kubernetes, which means it's a bit buggy, since it can distribute and stuff, but it's getting better really fast. It's actually quite stable at this point. So I think that even though we're NixOS people, containers are kind of the future. With putting NixOS on plain VPSs, you have to worry about topology. You have to worry about cross-service interaction and configuration time, because even though the module system should ensure that if you change one option for Nginx, it doesn't affect Apache, that's not always the case. And also VPSs generally tend to be too big if you want to buy them efficiently. So if you want to separate your services onto different systems, you're wasting resources. So that's what containers can help us with. And so, for example, these are the statistics from Serocal. You can see that we have 2 build servers, which, as you would expect, have large disks and are mostly full. Then we have we have the something, which I can't name, and generally everything else is below disk usage-wise, below 50%, and most things except for a few other things which memory-wise are above 50, which in this case is just Vault, and the miscellaneous stuff which just holds a lot of random things we didn't have any place else to put. So we could easily consolidate everything into containers and save a lot of resources, and that we're not very paying for but not using. So the effect of switching, in my opinion, is less work for engineers, because you don't have to worry about the topology and about the IPs and stuff like that. You don't get the interactions between services that I mentioned. And with better packing, you can have less machines and therefore save some money. And then we have a meme. So like we were talking about at the last talk, during the last talk, in my opinion, Docker tools and OCI tools are fundamentally flawed. It's nice that we can interact with existing runtimes, but stuffing Nix store paths into layers, which in the kernel there is a limit of 128 for overlay FS, which everyone essentially uses, is a bit troublesome, because it's common to have way more store paths than 128. And therefore, you have to somehow choose a heuristic. But that's complicated, and also to achieve a system where you're reusing the layers between different containers, you would have to somehow do the stuffing into layers outside the Nix store, so you can keep state between individual containers. With the current solutions, so OCI tools and Docker tools in Nix packages, if you, for example, wanted to run a Hydra in a container, the last layer will end up being 1.2 gigabytes in size. So if you change a config file, you're copying 1.2 gigabytes over the network. Yeah, also overlay has to do a lot of things to merge folders, which it doesn't know anything about, but we do know that the store paths, they are first immutable, and second off, they diverge at a very specific point in the directory hierarchy, so we can simplify lookup a lot. Then the next question is, what do we want to put inside the containers when we have figured out the store paths, which I'll come back to later. So one option is NixOS, which we already have, but NixOS is not really aiming to be small. It never was. By default, it uses systemd as the init and system manager, which can be changed. I'll get to that. And also, it's constantly changing. So if you want to do some large changes to it, it's hard to keep up, and you have to do an RFC and everything, which is annoying. So I tried this initially just by getting rid of it. You end up with essentially a Docker file, which is just a bash script. You have to create bin/sh and all the other stuff. You also need a process reaper. So normally people recommend dump init and a lot of other things. So you end up with a Docker file, essentially. We have the module system, so why don't we use it? And that's exactly what Arjan tries to do. I have a few issues with this configuration, and I'll go over them. So we essentially just have to say hi to bash scripts again. The core of the module system is a bash script, since Arjan utilizes bash instead of systemd to get rid of systemd to do the setup. The option boot.is container in NixOS is quite fun. If you want to figure out what it does, you have to grab the Nix packages repository to see where it's being accessed, which I don't think is ideal. It should be the other way around, but I see why it's not. Then this is just a personal thing, but I think that the services in NixOS, they're fundamentally flawed, where the Nginx module and the Apache module and a lot of other modules do way too many things, and it's really hard to know what they're actually doing. You have to read the 1.2K of lines to actually understand it, and even then it's not easy to understand. So when I'm doing stuff, I go a bit more minimal. And then we have the return of bash, where there are things done which should not be done by bash, like setting up etc pass wd, or like bin/sh and stuff like that. Or bin/sh is actually being set up in Arjan. These things should not be done by bash. It should be done by the module system. We have it for that reason. And then just a minor gripe, I don't think that putting what I would consider physical configurations like the ports, or whether to use the host store inside the config for the container itself is a good idea. It should be separate from the container. So the question is whether we even should be adapting NixOS. In the normal world, we see Debian, Arch, Ubuntu, and I have a typo there, versus Alpine, and I don't think I see Debian being adapted into something which we can put into containers. Debian is just taken if you need it, but generally it's recommended to use Alpine as far as I know. So on our end, we have NixOS and kind of nothing, and that's what I've been doing for a year, kind of slowly. I have this distribution called NixNG, maybe Blood, the name is debatable. It's a NixOS-inspired GNU Linux distribution, which was made for containers specifically. So currently it uses Runit, which isn't great, but that will change someday. It's stable, it works, it can run a lot of things. The modules, they generally correspond to NixOS modules one-to-one. And as for the testing, we talked about NixOS tests in VMs. If we got support for user namespaces in the Nix build, we could do it through containers with this. So the point is of NixNG is that it's an experimentation ground, at least has been for me. So I invite all of you to come and do something weird. I don't really mind the weirdness in the repository as of now. It's a way smaller code base, so you don't need to change as many things, and you're also less likely to break something if you change something. I think the deviation from NixOS is good at this point because NixOS has gotten quite large. And I'm not saying that it's bad. I'm saying that we need to experiment with new things again. And that's what you can do here. So what about the layers? Let's get back to that. There's this thing called erase your darlings, which essentially means that you do not have anything in the rootfs but the Nix store. And the Nix boot system sets up everything. And we can do that in the containers themselves using bind mounts. So we can run the rootfs in either Kubernetes, which I'm not familiar with, I don't like, or we can run it in Nomad, HashiCorp Nomad, I mean. Nomad has a notion of task drivers. So the nice thing is that you can take literally anything, even a punch card reader, and hook it up to Nomad, and it will run it. It doesn't care. So I've built an experimental driver which takes the container driver by Roblox, tapes on Nix, and hope it works. And hopes it works. It actually works, though. It has a few bugs, but those bugs come from the original task driver, not my changes. But it's still great as a proof of concept. With the simplicity of Nomad task drivers, we can do literally anything. We could use bubble wrap. We can even do it in Rust, since it's over gRPC. We can adapt the Docker driver in Nomad itself, which is the most stable out of them all, since you can actually force Docker to run rootfs if you're really smart about it. And we can also directly just call run C or any other option you can think of. So, and what we get by using Nomad is that we get interop with Docker containers for absolutely nothing. Nomad's design allows all types of tasks to, if the task driver is set up correctly, which isn't hard to do, they can interop via the network, via file system, and via, they can also like mount volumes over NFS. So we don't lose any functionality, we just lose some size and annoyance. And as for the future, well, the task driver needs work, a lot of work. It works, I've been using it. It's been running in a state of not doing anything at Serocore for a while, it's stable. But most work is needed in NixNG itself. I think that the rename is due because the name doesn't really roll off the tongue. And also we need a new init system because run8 is not amazing because it boils down to bash scripts again. My idea was to write something new and experimental. We could do we could use lots of processes communicating over something standardized like MQTT, for example. And then the processes would ask the others to do something, and we could easily replace them one by one with other languages or other implementations if we hold to a spec. So that's all. And I have to thank Serocore, of course, for allowing me to be here. My friend from Bratislava who helped me with the initial design of this presentation, two people from the NixOS Discord server, one for proofreading and one for running a test version of this thing for a while. My dad, who doesn't know anything about Nomad, for listening to my ranks, and my friends in uni suffering through the initial versions of this talk, which was just me looking at my notes and trying to say something. So yeah, that's all. You can contact me on Matrix via email, and the laptop just died. Okay, if you want to contact me, then come talk to me. I'll give you my email and my Matrix and everything. So that's all.
Thank you.
Good timing.
So
yeah.
That's very energy efficient, actually, because we're not using any more power than necessary, apparently. Are there any questions? No questions? Yes.
I think you briefly mentioned that you were using the Nixos modules that look that mirror the existing Nixos modules, but I guess they're based on Nomad service runners in some way.
No, it's separate. So like if you have the users.users option in NixOS, NixNG does the same thing, but its own way, since I'm not using systemd. I can't rely on systemd. But the modules are close enough where you could feasibly make a transpiler from NixOS configurations or modules from a subset, right? From a subset of NixOS, the option set, to the options of NixNG and get it to somehow work. If you look on my GitHub for example, the Hydra module, there is a header MIT license code begins here, and then 500 lines later ends there. So like I just literally copied part of the NixOS module into my own module. It's really similar. You just have to, generally only the config changes because you don't use systemd.
Okay, so the interface is about the same, but the implementation is different.
Yeah, you can keep the interface about the same, but like you don't have to. That's the nice thing.
Yeah, thanks.
Any other questions? No? Okay, thank you again, Richard. Or no, just looked like you wanted to raise your hand. I'm sorry. Thank you again, Richard.
Great timing.
So we are going to have a little break right now, and we're going to start at 11 sharp with one again. Okay?
It literally turned off.
Is that good? Thank you very much.
Yeah, like on the last slide when I was like, okay, you can contact me via Matrix, email, died. I was like, if you want to contact me, come talk to me, I'll share my details. Yeah, maybe the voice attenuation, I was a bit monotone, I think, but it was way better than I expected. Oh, right.
Thank you.
Could I request everybody to slowly but surely start going back to their seats? We are about to start again. I said 11 sharp, please. Could people please go back to their seat? I'm about to start again. And can I ask Ron on stage? I can also ask not nicely. That's also completely possible, but I'd rather not. Okay, nice. It's 11 sharp and everybody's sitting. A wonder. No, I'm feedbacking. Okay, I'd like to welcome Ron on stage. He's been on stage multiple times, so I have no need to introduce you, but I'm still going to do it. So please give a round of applause for Ron. Ron, stop preparing your slides.
1, 2. We're good? Very cool. That's what Flock says. Kidding. Cool, cool. One, two, three. You guys can hear me okay? Brian, can you come here for a second? Okay, thank you. Very good. Awesome. Again, thank you guys very much for coming. I'm going to kind of touch a point that's near and dear to me. I'm bad with naming, so I called it Strong Nix because it's supposed to make Nix stronger. Very straightforward. All right, I think I introduced myself yesterday, but real quick run through. Software engineer, IDF, startups, developer products at Facebook. Big on nonprofits, so I love things like this. I love organizing it. I love seeing people. I love just, helping out. And Flux now. Share a little of my Nix backstory. I do have to thank my wife for letting me do Nix. About a day after I proposed, I took her to NixCon Paris. That's actually intro, but this is NixCon Paris. And she's still with me. So that's also a picture of Ryan before the haircut. Other than that, I've been quite busy, so excuse if my deck or presentation is higher. We good? Okay. Excuse if the deck or presentation is a bit chaotic, but yeah, this is a picture of me working on it 5 minutes ago. But let's get into why I'm here and what I'm talking about. I hope this is good. Okay. So a few key topics I want to discuss: strong NICs, why, what it means, the key areas, and the inflection point. Learning from our neighbors, it's another effort that we did as part of the board. And then empowering teams and community power. As I said, I'm really great with names, so excuse them. Why? Why strong NICs? What does it even mean? So NICs over a decade ago, and since then has solved many, many different problems for a lot of different engineers. For all of you sitting in this room, it's just technical masterpiece thanks to Ilko and a lot of contributors and members. We've grown, as you've seen in the presentations that we've had in the past few days. We have thousands of contributors, and we have one of the more active open source repositories in the world today. But as our friend who I think did one of the best presentations I've ever seen at NICS yesterday said, we want to give him more friends, right? We want NICS to grow. And we are growing. Just in the last survey, as you've seen also yesterday in some of our presentations, 30% of the community today is comprised of people that joined just in the past year. And in order to keep that growth, we need to create clarity and confidence across NICS, the community. And I think one example I would like to give on the why here is as we grow, the community is going to change, right? It's going to kind of start bringing in the less NICS experts, right? The more new to NICS or completely unfamiliar with the concept, where we talked yesterday about the principles of NICS. Folks that are software engineers, but just have not been exposed to this at all. And while NICS is free, it's open source, it isn't. Every one of you here is paying for it. And everyone that's going to be joining is paying for it. They're paying for it with the risk that they need to kind of take in order to switch their infra, switch their OS, or rely on a new technology. And they're also paying for it with time, right? Obviously, onboarding has been, documentation is a key topic, and there's going to be a good talk about it today. So it's not free. And therefore, the why, we need to either reduce that risk and time, or just make it much more compelling so that they can understand why they're taking that risk. Cool. Let me lost my mouse. Cool. So first, what does this mean, right? What are the key areas that we think we should kind of look into and see how we can strengthen that inflection point, which I'll get to in a second. Number one is increasing our general resilience, right? So when someone's looking at NICS or looking at the community, they're, like I said, taking a risk. And because we're a very kind of lower on the stack level, we're an infra technology, that risk has upstream impact on almost everything they do. So when they look at us, they need to kind of feel confident, not just in the tech itself, but also in the general community. And making sure it's a community that's supportive and helpful. So some of the areas that we've been thinking about in terms of general resilience has been the fact that the growth will start putting more strain. We'll have more contributors, we'll have more users, we'll have more people asking questions. And some of the areas that we've been looking into has been, I think, things that have been called out, right? RFC, collaboration, general support. Another area of resilience is that imagine you're an external user, you have no clue what NICS is, you come to nixos.org, you might visit our discourse or matrix, and we want to see how we can provide that clarity, right? We want to see how we provide both clarity and clear governance, so people know what's going on, they can kind of like understand and have it seem straightforward. So I think this has two facets. Internally to us, it's exposing what the community and the user needs are. We talked about it in terms of like the surveys and the feedback and just making sure that we're doing the right things and prioritizing them. And from them, they're of course prioritizing it correctly. And really showing an external viewer how things are done in Nix. Because when someone comes in, they haven't been to NixCon, they haven't spoken to Ilko privately, they haven't interacted with Nixers potentially, and just helping them understand that very clearly is going to be a focus for us. Externally, it's again the things that I mentioned earlier, right? It's helping them jump into Nix, but also reducing the concept and of the risk involved with taking on Nix. Advocating, pretty straightforward. I won't add too much on that. I think it's just making sure that we are all advocates of Nix in the external realm. I think there was a ton of great talks on how we can be better at that. But positioning, I think, we talked a bit about the marketing team. Where is Nix positioned? I'll click through a few pictures later, but when I come today, right, to a, let's say, we're in France, right? We come to like a French restaurant, or let's say we go to a crepe place, right? We're going there to get a crepe. They're not advertising the fact that they have like Coke in the fridge. They might have it. Once you get there to get the crepe and you want a Coke, cool, they have it. That's an added value. And I'll touch on that in a second. General ecosystem, I'll talk about that as well. Community is going to change. It's going to grow with people that are outside of this room, and they have different perspectives to software engineering, different enthusiasm to software engineering, and we need to see how we can kind of bring them in and embrace them with a warm Nix hug, not a too hot one. And that kind of ties into setting up the newcomers to success. So in terms of positioning, I just found this graphic nice. This is the DevOps ecosystem. Be curious to say, where are we? No, you need to choose one. Where are we? There's planning and coding, there's building, testing, integrations, there's CI/CD, there's release and deploy, there's operating and monitoring. Nixonator is pretty on point, right? We're all of it. Now, there's a few analogies I can use, but yesterday we went to a French restaurant, and one of the Flux team members really likes trying new things. So we saw in the dessert menu something called the Big Baba Plug. We can't force an entire cake down people's throats. People have a view of what they do. They have a view of how they use it. They're used to doing it. They were taught about it in college and the university. Their friends explained it to them once, and forever they don't want to leave it. There's politics in software engineering. For us, maybe less because we're very open source, but once we step outside to the engineers that are working from 9 to 5 and all they care about is being a software engineer in order to come bring a paycheck and then do other things, they have different considerations, right? And this doesn't work. We need to be able to tell them, maybe it's all of it, but we need to be able to tell who's coming to us and then why they should come to us in order for them to come in and then go and see, oh, shit, it is all of it. Now I can grow into the rest. This is what I did about 5 minutes ago. I'm great at drawing. I have lots of skills, guys. You asked about board composition. I'm the artist. The inflection point. So you've seen this yesterday. We talked about it. Excuse me. We're growing 5x in like 2 years. That's great. But really, this is what's showing us just the beginning of where we're at and kind of where we want to go, right? We want some petas on the, no, I'm kidding, petabytes on the menu for us here. And the real question is, there's two. What does it look like at the top so we can build, we can work backwards to make sure that we set that up for success? And then along the way, how do we maintain it as a community? Right? So again, this has been seen across like Nix awareness, the fact that 30% are newcomers, and then some of the metrics that we shared in the opening keynote yesterday that you've all seen. Now, as I've stated earlier, right, a lot of this growth is going to go beyond this room into people that just have different concepts of software engineering than we do, and use it and utilize it for different ways and are more risky or less risky. I would assume off the bat that they're going to be less risky in terms of the risk that they're willing to take. They're going to be engineers that have less time to dig in, right? They want to take a piece of Nix. They want to go into Nix, but we need to kind of help them do it. And on the other side, the things that we're thinking about, and I would love community support and ideation on how we can do it, is how can we introduce more entries and escape hatches into Nix, right? Allow people to that beautiful graphic that I had before, come in somewhere, but leave before they have to finish everything. So for instance, more sandbox learning, that's something that's very kind of starting to be common in the general industry. I come in, I can play around, I can feel the power, and then I can understand why I want to use it. More practice projects, partial integrations of Nix, like I said, and really mechanisms to help us help them test Nix out, right? Take it for a test drive. So this is the generality of strong Nix. I think this is a lot of, you guys ask questions about the board and what we're trying to do. This is a big part of what we're trying to do, and this is the reason I'm talking about it is because we're not going to be able to do all of this without all of you, right? So I want to kind of start building up and collaborating on things in that area. Now, some of the other things that we've been doing is we've been, click the wrong place. There are successful open source projects that we can learn from. Some more, some less. But again, we're not the first open source. So we've started talking to a few, and we wanted to share kind of some of the key takeaways that were shared from it. So we talked to Plone, Linux, Rust, Haskell, presidents, PMs, chairwomen, chairs of the board, and really just kind of started asking them, what worked, what didn't, what would you, I think the main question that I really appreciated was, if you could do it all over again, what would you change, right? What would set you up for more success or given you less pain or potentially skipped a failing point? And I think the things that most stood out, at least to me from those conversations or to us, were these 6 things. So I'm going to kind of just run through them. And by the way, I do at some point, once we have time, just plan to release all the notes from the interviews. I think one of the key things that came in, and we've been discussing it, is that the foundation serves the project and community, and the community is served by the project. Right? So the concept here, and I know it's an ambiguous one, it's very macro, but the concept here is that the foundation, that's the core principle of it. And again, why am I emphasizing this for probably the 10th time across the 2 days? We can't do this without you helping us understand what this means, right? Now, make sure that the Nix community stays a greenfield. By the way, I replaced Nix, I think, with Rust here, just to make it more sense. Stays a greenfield than anyone that wants to join. I don't know how many folks kind of understand the depth of this statement. Greenfield means that at any time for decades to come, anyone coming into Nix will be able to easily bootstrap from the ground whatever they want to do with it. Make it always accessible, always welcoming, and keep it that way. Integrate intentional priorities and plans, make it explicit. So I think one of the other concepts that came up was that a lot of these communities benefited from starting to think about where are we going and how can we be intentional about it? How can we collect that feedback, right? I think in other terms, it might be called kind of like the product cycle. but looking at our open source as if it was a product that we're trying to offer to these people that haven't been blessed with Nix. Invest into empowering collaboration across the community, so teams, so I'll touch on that in a second, and we also touched on it yesterday, but the whole concept of team empowerment was really also strengthened by, I think, talking to both Rust and Plone, and I'll touch on it again soon. Drive, I like this one, drive the right awareness to the world. Nix principles. We don't have to force you to use Nix tomorrow, but I think another big gap that we have today in getting that inflection point even further along the road is the principles of Nix, right? Reproducibility and the things that we mentioned yesterday. Do other people understand it? Do they know why it's impactful and why they need it? And I think we do this insanely well, but keep it up in terms of prioritizing like the strong community ethos and the culture of Nix itself. Jumping into empowering teams alpha. I know some of you probably haven't seen it. We posted a little post about it this week out of all the Nix craziness. Really the goal that we kind of came into with empowering, with the whole team empowerment concept, and I think everyone touched on it, came from the surveys, came from people talking about it for probably years, and just came from the general need within the community. So the idea here is that we want to improve the functioning and the impact of all of you by giving you the tools you need and setting you up for success, and also giving you direct, actionable support from the board and the foundation, of course. So what we hope this will achieve for us is that we hope that it will create a scenario where the community and the teams in it have clear mandates and responsibilities, but also have clear ownership. I personally believe that in a lot of instances, that is the path to being empowered and being able to do what needs to be done, right? Having that ownership or being, whatever that mechanism is, but just you knowing that, you know what, marketing team, I think this is a very easy one. They own the website, right? So if they have an idea, they want to test it out, they can roll it out and do it, but we need to spread that out to a lot of other areas and a lot of other places so individuals can just come in and not be stuck in a loop of approvals all the time. We can make mistakes, but it's better to make a mistake than to be kind of like held back in some sort of status quo waiting for something. Reducing overlap, so ideally through creating transparency and better communications, people will be able to contribute, but also people will be able to know what's being worked on and what they shouldn't. Not shouldn't, but don't have to. Like I said, direct board support and funding, and I think one of the main concepts that we also talked about is removing bus factor, right? So if we want to look at it in the positive light and not in the bus factor light, there's a few people here, some of them in the room, that if they win the lottery and decide to completely disappear from the surface of the earth, we'll have a few sleepless nights to figure out what the hell we're doing. So going into the empowering teams, we came up with a tiered model. Sorry, actually Rust and Plone and a few other communities came up with a tiered model. We added a third tier. Their model had community and critical. Our model has community, formal, and critical. The whole concept of why the hell do we even have tiers is because in order to give, we have to create some sort of structure. Otherwise, we'll be in a loop of, okay, where, this one's asking, do we go there? It has to have some sort of prioritization. So starting off with the community, very point blank. This is the community today with just a bit more support. It means everyone and anyone can open a team, a collaboration, do whatever you need to do. But now we want to make sure that you guys also have access to the website, right? Some sort of like team creation template that will maybe help you out, just get your thoughts in excuse me, in a structured way. And beyond that, we also plan to introduce, just in general, start collating like a Nix team knowledge base, where we have so many teams and so many people doing incredible work. I think Valentin's going to talk about documentation very soon, but he's been creating templates and has been creating like these things for the team itself. The Nix team with Teofan, there's a lot of things that if we just ported them out into a template, when I want to come in and create a team, it'll be much easier. So that's generally the community. I think some of the examples we had of these teams were like Emacs, static builds, Mac OS, right? But really it's anything and everything. Formal. So formal is the middle tier that we introduced. Most of the communities we spoke with had community and critical. Critical, I'll jump into that in a second, but critical is like, if that team disappears, they win the lottery and go, we're in deep shit. Formal is the middle tier. Formal is, we don't want to have such a huge gap between, oh, these are the critical teams that we think are critical and we support, and everyone else, greenfield, great. We wanted to have an opportunity for folks to move into like a middle tier where it's still very impactful, but if they disappear, we're not going to be, not sleeping for 2 weeks, and still give them the support that they need. Some examples of formal teams is like, for instance, the Nix team or the Doc team, or teams that are directly impacting the trajectory of Nix itself, but we'll be, we won't need to kind of chaos firefighting mode if something happens or something is delayed. A little bit more about what this means in terms of the support that we plan to give. So we plan to release a Nix Foundation funding mechanism to all of these formal teams and beyond, so formal and critical. If you need funding, if you need to do meetups, hackathons, you need resources for your teams, that's something that we want to introduce. Non-monetary support. Thank you. Non-monetary support. So going beyond that, right? You saw the board yesterday. There's people that are actively involved. We have board observers. We hope to have more as well. We want to be able to, like the board is going to be actively taking time from their plates. And if formal teams or critical teams need us or just need general support, we'll be the first to raise our hands and kind of provide that SLA to all of these teams that will be there if needed. And of course, just like some smaller things like added visibility across channels, so like the formality, right? The website, the social medias, the discourses, and really kind of working together on that advocacy piece. So that's what we're providing. And in order to do what we said in terms of empowering the teams and making sure that the teams get stronger, we're also starting to alpha test. By the way, this is all in alpha, it's in big there. We're testing this out, so we'd love the feedback, but we want to also kind of provide guidelines to responsibilities and accountabilities that we think teams should have in order to be at a higher level. So some of the things we've been thinking about is like tracking membership and having a point of contact, clear ownership statements. So why does this team exist? So others can understand and kind of provide that transparency. Long-term vision, public issue tracker, and then just general ops, like have all your meetings on the Nix calendar so others can join, know about it, know its recurrence and who's there. Moving over to the last, critical teams. So again, like I said earlier, those are teams that if they disappear tomorrow morning, we need to figure things out. The idea there is to both have all the formal capacities of the previous ones, but then introduce a few more. One is direct commitment of the board to be involved, either as a contributor to that team or as someone that is like at a, like a army 12-hour response time, like something happens, the board is involved, and also as an escalation path. So all critical teams, like a question I can ask is like, if you need to escalate something that is blocking Nix, where do you go? Just making sure that that's very well defined, and there's a definitive stopping point in terms of if that person doesn't answer and that person doesn't answer, here's my phone number, or here's like someone that is from the board that is going to jump into this no matter the time, the hour, where they're at. Quarterly plans and retros, roadmaps, and really these are parts that we want to help with. Some of the teams that we've been kind of looking at to alpha test this with is like infra, and we also imagine the RFC team potentially being in that mix. And really that's it. So the whole concept of empowering teams right now, it's in an alpha phase. We release an initial concept and idea in a post. We want you guys to give us that feedback, and I think I've already started seeing people comment. Apologies for not responding. It's been NixCon. Get involved if you care about it, if you have ideas, and that's how we kind of go from there. And last, Nix community power. So I can't state this enough. The only way that this works is if we have, if we're able to reach like an aligned front where we're all plowing through these things. So really how we do this, right? We're trying, I think I'm going back to that graphic, we're trying to do quite a bit, and we all want to see Nix grow. And I think that I am super bullish on the fact that Nix can take over the world. We can do quite a few things that are going to be, if I told this today to a non-Nix developer, they would probably laugh at my face. Why do you need containers? I think we had a lot of container talks. But to do so, it's, there's a cliche kind of point of like, it takes a village. It probably takes like an entire citadel of like 50,000 people, but who's counting? Again, thank you, and happy to kind of move to questions.
Thank you, Juan. Thank you, Juan. There we go. Are there any questions?
I'll save you the walk because you've been walking a lot. Ron, I like what you're doing. It's great. You're studying, you're talking to Rust, you're talking to Haskell. Have you talked to Red Hat? Have you talked to SUSE? Have you talked to these people about growing an operating system?
Yes. So, I mean, I've personally talked to Red Hat and SUSE Linux, but I think that's a good point that we can kind of explore more of how they took, I think they took it at a different approach, more at a commercial approach, but I think that there's probably a lot of learnings that we can get from it.
To me, it was commercial takeover. Yeah. So basically, these were independent companies, and then big money came in, and then these companies changed. And Nix is kind of my little baby passion. And it ain't my first rodeo. I've been in it. I'm the oldest Nixer in the room by a long, long way, right? And I just don't want the repeating of history. So talk to them and see where the.
What would you ask them? What would you ask them?
Why did you sell out? Why didn't you just keep going?
Red Hat?
Yeah.
What do you count them as selling? But I'm confused.
Well, we'll talk it offline, man.
Okay.
I don't want to bore you.
No, I'm. Good question.
Okay. When I first came to NixCon, I was a newbie, and it's only newbies in the room that have never used Nix before. Okay. So I'm reading the newbie track unofficially upstairs it's 14 flights up the stairs. And if you want to learn about what reproducibility is and Elko's amazing work, then I'll be up there all day because I've got to work. So come and drop in. So sorry to steal the stage.
Put the mic a bit closer to your face.
So I have actually an objection on the criticality of teams. So I think that the marketing team should absolutely not be critical, and also the RFC team is not critical, because simply I think as a community we are not ready yet to take the influx of new users that we would produce if we had successful marketing. What do you think about that?
Two things. This is why we've been butchering this topic like hell for the last 2 days. And this is why I put alpha in big bold letters earlier. I completely agree with that statement. I think we aren't ready, right? And if we want to be blunt about it, I think a conversation over beers is more fitting than a recorded talk. But I have some very kind of like strong opinions on our current status, and Valentine wants to continue. So again, like very bluntly, we aren't ready. I think making the marketing team a critical team doesn't necessarily mean that we're going to open the floodgates to 10 million people tomorrow morning. It's going to be sorry, Brian. Brian is like, Brian's the hype guy, so. It's going to take us months, if not years, to reach a point where these teams are like, look at Linux, look at these other distributions and repositories, right? To get to the stage where we're ready for it. So it's something that has to happen. I mean, we have to start structuring them now, right? Because the inflection point, and we also don't control the inflection point. It's happening with or without us wanting it. We're seeing it. We didn't do, we did kind of do some things, but we didn't do like something grandiose, and things have 5x, right? And people, like I said, the people that are coming in externally, some of them have an appetite for a one-time thing. They come in, they get scared, they get shell-shocked, and it's going to be really tough to convince them to come back. So I think that's my view. But you're right.
Yeah, I agree. I think we should first fix the basics, the substance that already is well explored, and only then let people come and get a taste of that. But if you have more concrete thoughts, please share it with us. Right now, why not?
Yeah, no, I think I just shared it. I ended up sharing it. Like my thoughts on how the inflection point is not something that we decide on. It happens. And it's something that is going to be kind of tough for us to walk back from if we're not able to structure it correctly.
Thank you, Ron.
Thank you.
A round of applause again for Ron. Could I ask the lightning speakers to start gathering and my dear Theophon to plug his computer in? Don't fall, please. A round of applause for the lightning speakers as well, but they're going to be going fast, so quick applause.
Okay, so hey everyone. I'm sorry you're going to have to rewire your brain a little because we're going to get down from Ron's very high-level talk on the future of the community to a very mundane technical problem that we've been solving. So what I'm going to talk to you about today is how we can make the Nix daemon run as much as possible without being root. So, well, let's first try and understand why we want to do that. So for a security-minded person, running Nix like in multi-user mode, essentially it's running this big C++ code base. I've just checked, it's around 60,000 line of code. That has never been properly audited. That's doing some very dangerous things. It's accessing the network. It's running its own custom binary protocol. It's essentially running untrusted code because like the daemon is just running the derivations builders. And so that's the kind of things that, well, I don't mind running it as root on my laptop. I mean, it's a single user machine, but if you're running it in a big enterprise context, you definitely don't want to run this as root. So it turns out that Nix fundamentally doesn't require to be root. Like you can do a single user installation. You don't need to be root, just need to have /nix. And well, even that you don't really need. But that doesn't work when you're using the daemon. We can try it if like, whoop, the things are not coming in the right order. But if you try to run the Nix daemon and then as another user, you run a Nix command that tries to talk to the daemon, you're going to be greeted by some nice errors with you can see the red errors popping up in the middle of the error message. And it turns out that there's two more or less bad reasons for why the daemon requires to be root. I mean, they were good originally, but now hopefully we can get rid of them. So the first one is that the daemon is trying to do some profile management for the client, trying to be helpful, but too helpful for its own good. And the other thing is the garbage collection, where for some reason that we're going to see right after, currently the daemon wants to have root access to the system. So, well, can we fix this? Well, let's see about that. So the first issue about the daemon trying to help the client a bit too much, turns out that that's mostly an historical artifact. And we can just let the client do all the profile management by itself. That works. That even makes the code nicer in a lot of ways. Small problem that's kind of breaking the backwards compatibility in a small cases, which is why it's still there. We need to figure out how to migrate things properly. So that's not too much of a problem. The other problem is the garbage collection. Why does the garbage collection needs to run as root? Well, it works if you're not root. It works even very, very well in that if you build something, well, you have this nice result, symlinks, you can run it. Now you run the garbage collection, and the thing just disappeared, which shouldn't be the case. Like you have a root, a GC root, so it shouldn't be garbage collected. But if your daemon is not root, that's not working properly. So let's look quickly at how the garbage collection works to understand why it is so. So what happens when you run Nix build something is that Nix will create what's called an indirect root. So it's going to create something under Nix var Nix, its own internal magic. That's going to be a symlink pointing to the result path that you have. And that result is itself a symlink pointing to something somewhere in the store. And so Nix will inspect this Nix var Nix GC roots thing, follow the symlinks, and see that, oh yeah, okay, hello is something that can be reachable. I don't want to delete it. Now, if you remove this result symlink, then great, then you remove the symlink path to the store. So Nix, well, the thing is no longer alive as far as Nix is concerned, so it can be garbage collected. That's great because then you can just, you don't have to bother about what's in the GC roots things. You just have your local symlinks. You can delete them to remove the roots and you're happy. But now what happens if now the daemon doesn't have access to this result symlink? The symlink is there, but the daemon doesn't have the rights to read it. Well, as far as it's concerned, it's like if the symlink didn't exist. The thing is no longer a GC root. And so it can be garbage collected, which is exactly what we had before. And that's problematic. So can we get rid of that? Yes, well, we can just add some layers of stuff on top of that. And the best solution we found so far is that let's just make the Nix daemon run as a normal user, but add another daemon that's going to run as root and just do that, which is a bit silly, but it turns out that it's nicer in many ways because only that new daemon will need to be root. And because it's a very small self-contained thing that just has to traverse the file system in many ways. First, it's smaller, easier to audit. And also because it has a very restricted set of features that it's only doing a very small set of things. It just needs read-only access to the system. It doesn't need to do any network access or anything. So now you can sandbox it properly. And that reduces the attack surface of Nix a lot. So that was all. I've already exceeded my 5 minutes. Sorry about that. And I'm letting the next speaker come in. Thank you.
A quick note, if you have questions for the lightning speakers, there's a discourse post that you can ask questions on.
All right, hello. I think everybody can hear me. I hope so. My name is Martin Schweikhofer. I'm going to talk to you about reproducibly building artifacts with embedded signatures. And the first thing we're going to look at is a dependency graph. Except I'm just kidding, that's kind of some visualization of dark matter, so it's not a huge dependency graph, but it could be, right? This is a nicer dependency graph, but we heard a lot about dependency graphs already. It's just kind of where I'm also starting from, so we have some outputs here, and then like a set of arrows that go into one of those, like the boxes are the outputs, and a set of arrows that goes into one such box is kind of a build step that produces that output. And that's conceptually where we're starting from. And we might have a signing step anywhere in our dependency graph, right? No matter if it's a huge one or a small one, there might be a signing step in there, and that's what I'm talking about. So the first thing that doesn't really have to do with signatures is, but it's important, is that we have this Nix build rebuild command, which lets us rerun individual build steps, but it's individual steps, right? So we're not producing the graph again, we're just rerunning the bottom node, right? And there's a few issues with signatures specifically. They might be anywhere in our output artifact embedded somewhere, right? They might be produced by any build steps. Actually, Nix is quite nice for reproducibility because we can kind of split up our build into different steps and then deal with reproducibility on an individual step level, which makes things easier. But with signatures, our signing step might not be deterministic. That's an issue with some signing schemes. But mostly we probably don't have access to the key, right? So the reason why we're wanting to reproduce an artifact is because we don't want to trust the person that's producing it. So we want to be able to do it on our own. And with signatures, that's kind of incompatible, right? And still, if we can't avoid having a signature somewhere, we can still manage that problem, and that's an improvement. And we can manage that problem by verifying the signatures. And this is something that we can model in Nix. So the rough idea is this. We have some unsigned thing that we want to sign, and we have a signing step that then produces some unverified artifact. And then we have an explicit verification step, and then that produces a verified artifact. And the key goes into the signing step, but it doesn't go into the verification step. So one derivation for signing and one derivation for verification. And yeah, this means that if we can reproduce the verification step, we don't have to trust the signing step any longer. And now let's look at what that can specifically look like in Nix, right? So I have some Nix code here, and it's pretty unsurprising. It just takes the unsigned thing and then runs a command to sign it. This is probably going to be impure in practice. And then outputs the signed artifact. But this is not the full story, because here we have a first kind of weird thing, which is a load-bearing comment. So this comment is required to make substitution work correctly with what I'm constructing here. We're putting the key fingerprint into the derivation here, so that substitution will actually only substitute things that have the correct, a signature with the correct key fingerprint. And actually, if we were to want to properly do this, we would want to verify the signature here as well, so that we can't upload something that's signed with the wrong key by mistake. And then the second step, the verification, looks kind of similar. It just takes the input, verifies the signature, verifies that it's signed with the correct key that we're expecting, and yeah. And if that's the case, then it just passes the output along. But here again, there's a caveat. We would also have to verify that the unsigned thing matches what we expect, to really not have to trust the signing derivation anymore. And there's a last thing that I did in here, which is this environment variable that says verifies. That's kind of a bit of a magical thing. So it's metadata actually, and it makes the verifying derivation point to the signing derivation. And we can use that information in tools so that they can manage this additional information and let us know, oh, hey, this one derivation might not be reproducible, but there's some other derivation that exists that is reproducible, and it verifies what the other one was doing. So it's kind of a better state, because we can track and manage that part of our build process that is not reproducible. And that's everything that I have. Thanks, everyone. If you have questions, please ask them later on. Please say hello. I'd be happy. I'm looking for collaborators on this and other things related to reproducibility. Thanks, everyone.
Hi everybody, I'm Ariel. Let me tell you a story about how I started using NixOS. My friends were like, hey, this is great, it's reproducible, declarative and everything. So I'm like, cool, I'll create a VM and I'll create a user on that VM so I can play around. And it's declarative, so I'll set a password for that user declaratively. Should be easy, right? So the very first option I looked up was how do you set a password for a user? Users, name, password, like pretty easy, right? Oh wait, the help says don't use that because it's terribly insecure. Turns out Nix is not great with secrets because Nix is a package manager, and package managers don't typically carry secrets around. They build, especially for Nix, mostly open source software. So it really wants to put all the source and all the products in the store, and the store is word readable. But NixOS is an operating system, and operating systems do need some secret management, like you have stuff in Etsy or in your home directory if you're using Home Manager, like that stuff. You don't want everybody to read it, or at least not in clear text. So I wasn't super impressed by this first experience. So the next thing I did was look at, well, how do people manage secrets in there? Because it's a problem we've all faced, or like many of us have faced, this is a fertile ground for invention. There's this wiki page that's completely unreadable on the screen, that's kind of unavoidable. It has 8 entries. They're all actually very interesting and good, but basically what they all do is they say, well, secrets should be managed outside of Nix. Like we'll just hook in either in like some systemd units, or we'll put that in the activation script, or like completely outside of all that, but just don't put it in Nix. And that works, but it has one small problem, which is everybody's doing different things and not in Nix. And that means that NixOS modules aren't really designed to work with secrets managed that way. And the second order effect of that is that this is making the easy thing dangerous and the right thing hard. Like if you do want to set your user's password, you're probably going to use that option. It's very attractive. And if you have a multi-user system, you're doing something really wrong that way. So we need to do something where what is right is easy. Otherwise, as an OS, we're probably going to set ourselves up for a big failure. So we're building on systemd, and turns out systemd has systemd credentials management. It's pretty easy to use, honestly. I mean, the command lines are scary, but that's just like systemd in general. Very quickly, what it does is it encrypts a secret to a per host key. If you have a TPM, it uses that to back that key. And nice bonus, it manages your secrets ownership and permissions for you because it only makes them available to the unit that you wanted there, which is kind of nice when you use other solutions in the wiki page. Many of them you have to manage permissions by hand. It's a little complicated. This actually is sort of used in NixOS. There was this issue that discussed, can we use that for secrets? And we closed it successfully, saying, yes, we can use that, but then we never actually used it. It never is it's not true. We used it in about 15 modules, but only for the unencrypted version where the secret is still in clear text. So doesn't quite work. But I have a proof of concept in creating with Aginix, which is one of the 8 entries in the wiki that encrypts to the per host key. So where can we go from there? Well, good patterns, I think, in NixOS tend to emerge from people doing something and recognizing it's successful and then copying from each other and just kind of evolving organically, and then it gets standardized. So I'd love to talk to people during the hack day about, hey, how would you like to use this in your system? Can we try some approaches? Can we hack on some tooling and see what works for you? And then, once that works, we can drive some adoption. Also, I saw somebody with a systemd t-shirt yesterday. I'd love to talk to you because there is one small to-do about asymmetric encryption for this in systemd. And that would make things so much easier. So come talk to me if you're interested in any of that. I'll probably be behind the bar most of today, and this is my contact info. Thank you.
Hello. Oh, nice. Hello everyone, I'm Maximilian. I'm also known as MA27 and I work for Mayflower as a systems administrator and software developer. And today I'm going to talk about one time where Nix became useful in a legacy project by accident. Also, that's my first conference talk, so I'm horribly nervous. So first of all, one confession I have to make is we never really used Nix in production. That's a longer story I can tell you after, but it's not really part of the talk. In fact, some of my colleagues were actually kind of skeptical about Nix, but more on that later. And today I'm going to talk about this one time where Nix became quite useful and yeah, actually by accident. So a little bit of background. The software I'm talking about is a big bunch of PHP code to create maintenance manuals for like big engines. And it was planned to migrate it to a new system. So as you can imagine, there's a big bunch of data we have to migrate. And one of the bigger issues is that there's a baked-in image editor. The biggest issue is, yeah, it's written in Flash. And we didn't manage to recompile the code, and we also had no idea what it was actually doing because none of us actually had experience with Flash. But we had to reverse engineer this mess because we had to migrate like the images and the changes of the images to the new system to make sure that these images are still editable in the new system. So the idea was basically to throw a bunch of test images against an editor and yeah, see what happens to better understand it for the migration. Unfortunately, all of that happened in 2021 and yeah, Flash was dead. So the big question is, how do we revive Flash for 5 minutes? Not that much longer, please. Sorry. So at first we were discussing approaches like building some Windows VMs, but then I had an idea. I was like, yeah, hold my beer. And I decided to use a NixOS build VMs. That's basically a small wrapper on top of the testing framework that Linus already told you about. And the idea was to build a recent NixOS VM and yeah, just install a Firefox from 1609 into it because back then even we had Flash support in it. And yeah, that's basically most of the magic. So I basically imported a tarball from GitHub with a revision from NixOS 1609, and I enabled Adobe Flash because even we didn't want to have it by default back then. And from this package set, I imported Firefox. Also, well, I obviously had to increase like the memory a bit, and I needed an X server, but it's not that interesting, so I left it out here. Now I thought, well, job is done. Unfortunately, I had another problem. So Flash is obviously unfree and not redistributable, so it is not part of our binary cache. And I had to build a few derivations on my own, but that was kind of a problem because, yeah, the download links are dead, which is actually a good thing, I'd say. So then I came up with another idea. There's this beautiful thing called archive.org, and I basically scrolled down the Wayback Machine until I found a working download link, and I did nix prefetch URL. And after that, yeah, I had a fixed output path in my store with a matching hash, so I could build the VM, and yeah, job was done. And here's a heavily censored screenshot of the result. That's basically a NixOS 2105 from back then. And in this browser, it's still called Nightly because in 1609, we weren't even allowed to call Firefox Firefox. And so basically, you see the gray rectangle is the part on the right, and it's some kind of engine. I've forgotten what it was. And yeah, we could basically reverse engineer the editor with that. Okay, and that's basically it. The first thing I have to say for the final notes is I hope you'll never ever need this because, well, if you do, you're in big trouble. But the interesting thing is it's fairly trivial to revive old applications with Nix. So first of all, we have a binary cache with all the build artifacts in it. So we don't have to like bootstrap a standard env and yeah, compile all the stuff on our own. We can download most of this stuff, but yeah, with a few exceptions. Then also it's kind of cool that we can instantiate any kind of old Nix expression. So we can like resume old projects at some point later. And yeah, if we've done everything right, we can get the same build result and can continue to work on it. And that's actually, I think, an underestimated feature of Nix that's kind of nicely demonstrated. I just needed a funny story to tell you about it. And I think it's important that we keep it that way. So yes, we're doing a lot of cool stuff with Nix. I really enjoy all of the new features, but I think it's important to remember that this is a property that yeah, we should keep. And finally, a fun fact. One of the colleagues admitted later that he was actually kind of impressed by what Nix could do, and he seems to just somehow have changed his mind. Thank you.
Check. Yes, the hotly sought after last talk before lunch. All right, perfect. Hello, I'm going to expand this a little bit if that's okay. Is it possible to up the text? Oh, yeah. Much better, much better. Hello, everyone. My name is Luke Perkins. I'm a Nix advocate, DevRel kind of person, and I work at a little company called Determinate Systems. You may have seen some of us give talks elsewhere at the conf. So home environments or workstations, whatever you want to call them. It's really hard to overstate how vital these are. They're, I think of them as basically the staging ground for your entire career in the industry. They follow you across jobs and programming languages and stacks. And because of that, I think that they're worth really major investments of time and cognitive energy. So let me tell you my story. I'm a macOS person about 95% of the time. My home end started the way it does for most macOS people. So I used Homebrew to install things, and I kept a .files repo for Vim and Tmux and all of that good stuff. So this approach was, of course, totally ad hoc and totally procedural, which is boo, hiss. Setting up a new machine meant spending a couple days messing around and trying to remember stuff that's missing in my environment. Some kludgy bash scripts, like that kind of thing. Let's scroll down. That's actually a little too big, sorry. There we go. And then I discovered Nix a couple years ago, and that in turn led me to discover Home Manager, which unlocked a whole new world of declarative possibilities for me. I threw away Homebrew and my .files repo and started doing everything in Nix. So Vim, Tmux, VS Code, shells, basically everything lives in one repo. I actually wrote about this on my personal blog a couple years ago. And now, as you'll see in a second, I've gone beyond even this with a project called GNOME, which I'll talk about in a second. So as I've used Nix and Home Manager over time, I've adopted a principle that I really like, where I divide my home environment into two distinct domains. So first, there's the global domain, and this is where I install and configure truly global stuff, like editors, Git, JQ, curl, wget, and all that stuff. I use Home Manager for this, of course, and it just never, ever, ever fails me. But there's another domain that Nix is also great for, and that's project-specific environments, as we know, with dev shells. So as a DevRel person, I'm constantly playing around with pet projects and frameworks and languages. And in these kinds of settings, it's really vital to pin your compilers and runtimes to specific versions, and also to provide whatever kinds of checkers, formatters, linters, and other glue tools that the project needs. And I use a fairly new feature for this called Flake templates. Now, this way of thinking has resulted in a project I call GNOME, or which is my Nix home. It's also a city in Alaska, where I am from. And GNOME is really just a Nix flake that exports absolutely everything I need for my home environment. So whenever I'm on a new machine, I can terraform that machine with just a few commands. So I install Nix, I build the Home Manager package, I run the activation script, wait a few minutes, and I have my super duper finicky home environment ready to go. So editors, tiling managers, shells, and everything. So Home Manager handles all my global stuff, but what about specific projects? Well, for that, GNOME provides a little script called proj, which initializes my standard flake template, which itself uses a GNOME exported library for building shell environments. So I had this makeenv function that enables me to string together some custom tool chains that I put together. If I need some random packages, that aren't inside of a tool chain, I can add them to extras, which is just kind of like gnome.packages is just like a re-exported Nix packages with some overlays. And then I have a standard shell hook for any kind of initialization logic I need. So this works great as a kind of quick and dirty approach. I run proj, I delete any tool chains I don't need, I make some adjustments, and I'm off to the races. But if I need to get more granular, I use a script called dbt, which initializes a specific Flake template. So I've created over 20 of them for a bunch of different languages and tools in a project called Dev Templates that I encourage you to check out. And this has cut the time I need to have a pure Nix dev environment tailored to a very specific project down to just a few seconds. Okay, takeaways, almost done. So first, this global versus project-specific distinction has enabled me to separate concerns in my home environment in a way that suits my needs extremely well. And of course, Nix handles both of these domains with style and grace. Second, GNOME is not a blueprint per se. I'll never finish it, and it's full of like idiosyncratic stuff that's of no use to anyone but me, and that's okay. But home environments are extremely important. So I urge you all to maintain a project like this. GNOME has saved me mountains of time and trouble, and Nix, right now, today, provides all the primitives you need to create your own long-lived Nix home. Thank you.
There seems, oh yeah. There is one more surprise speed talk.
Hello. Okay, so we're going to talk about Jitsi on NixOS. This is Cleve Higgins, and my name is Daniel Thagard. I work at Tweak. Oh, and how does the... You need to click it. Oh. There we go. And so we're going to talk at a very high level, give a high level overview of our work on open source video conferencing deployments and the relevance of NixOS for small collectives, community organizations, working with very little funding and resources and people. And so we were doing this work as part of Summer of Nix, which was an amazing opportunity and experience 2 years in a row. The first year as participants, and the second year, this year, as co-project leads working on Jitsi. And we chose to work on Jitsi for a few reasons. Obviously, we're all using video conferencing software all the time, and having an open source, self-hosted, end-to-end encrypted option for this seems really valuable to us. And NLNet and their NGI0 project, who are one of the main organizers and backers of Summer of Nix, think so too. And so they funded work into supporting end-to-end encryption for Jitsi, and as a result, packaging it on NixOS was an important priority for them. And so Jitsi is a quite complex open source tool. It has multiple server processes running together. And so This is an architecture diagram here. I'm not going to go over it, but you can see there are a variety of core components. It also relies on an external XMPP server and a variety of less central components and all of these integrations with other services as well. And so manually deploying it is quite annoying, but on NixOS already, just a simple deployment of the core services is trivial. We just set enable to true, basically. And this was already there, but we had a chance to work on more integrations and some of the things on the edges of the Jitsi ecosystem.
So one of the main things that we worked on in summer of Nix last year as participants was packaging Jibri. Yeah. And so Jibri is a Jitsi broadcasting infrastructure. So this is a separate component, which someone, I believe on the NixOS IRC, concisely described as a Java app that starts Chromium using Xorg with Selenium and then FFmpeg into the frame buffer. So it's a pretty convoluted software setup. And then from there, it can, from FFmpeg, either save the recording local to the disk or upload it or live stream it to something like PeerTube. And so the instructions to manually do that is, there's pages of setup instructions to manually set that up. On NixOS, with it packaged as a module, it's literally one line and the whole thing is running. And so the work to actually make that quite complex module was done by Puck for NixCon 2020 for the video infra a few years ago. And so for Summer of Nix, we were taking that, getting it up to date, polishing it, getting everything working in order to then have it merged into Nix packages. So now through just NixOS Nix packages, you can have that whole Jibri set up that on any other system would be very complex to get working. This year for Summer of Nix, there is another integration for Jitsi called Vosk. Vosk is a outside of Jitsi project that does offline speech to text, so closed captioning for videos. And Simon Bruder, one of the participants in Summer of Nix this year, packaged all of that. It was very impressive for Nix packages. There's a PR that's still open for that. It hasn't been merged yet. And that allowed for having a Jitsi video conference to have closed captioning. And then we took that package with Vosk, integrated it into Jitsi, and had that deployed on NixOS for the first time. Again, same with Jibri, taking something that the manual setup process for Vosk, it would be pretty complicated, and allowing that all to happen in just a single line of NixOS config. The PR is there, but it doesn't actually work because there's an upstream issue with the integration of Vosk into Jitsi that we can't work on because of outstanding issues.
And so there's more stuff to be done to improve Jitsi on NixOS. Right now, like a lot of Java projects in Nix packages, actually, we're pulling, or Nix packages is pulling pre-built binaries instead of building from source, and because dealing with Maven is frustrating, but that would unlock a lot of possibilities for patching and using experimental features. Supporting distributed deployments. Right now, the Jitsi modules expect all of the Jitsi core components to be running on the same host, which is not necessary. And unlocking additional Jitsi features like call authentication and more integrations with external services.
So this, for us, this example of Jitsi on NixOS and all the things it makes possible is a really clear example of how NixOS makes it possible for smaller teams, individuals, and projects that aren't well-resourced, aren't going to have their own platform teams to deploy something like Kubernetes, or don't want to be or can't afford to be on public cloud services, to do what otherwise would be pretty complex deployments in a straightforward way. So it really empowers those smaller kind of projects to have access to the kind of technology allowing declarative system configuration that is really clearly the best way to be doing things without needing those higher resource, more capital intensive kind of projects to do them. Thanks.
Could I ask the lightning speakers to quickly come back to the stage, please? We're going to be taking some questions. A few questions. I don't see Luck anywhere. Luck Perkins. Oh, okay. Okay. Luck will show up eventually, and he'll notice that they're taking questions. So if you have questions, please yell them really quick. They're going to be repeated, and then they'll answer, okay? So if there's questions, raise your hand. I'm going to let them select. I'm just standing here for moderation, so go ahead.
So the question was whether the rootless Nix daemon walk was about splitting the Nix daemon between one part that had no root access and one other that had root access. So the answer is yes and no. The idea didn't have time to elaborate on that, but that's so we want to do that for people who want to run the Nix daemon as a non-root user. But because that's adding more complexity, because now you have two daemons to deal with, that makes the install even more complex than what it is already. And because also a number of people don't care about that, and in particular, if you're running NixOS, having Nix run as a non-root user is a bit of a joke, because Nix is the thing that's setting up your whole system. So even if it's not root, it can do whatever it wants. So the idea is that it can leverage an external daemon to do that, but it can also directly have that, like the way it's working right now, as that as part of the main daemon, in which case the main daemon still requires running as root.
So the question was whether uncached artifacts are somehow discoverable, and the answer is kind of yes. So I think you need to check in a derivation whether meter.hydra platforms is empty or if the license is unfree, if I recall it correctly.
Because not everything supports hash passwords. Sorry, the question was what's the advantage of using systemd for secrets versus hash passwords? Not everything supports hashed passwords. And depending on what you're talking about, like hash passwords might actually already be in a rainbow table. So that's like sort of problematic. But like there are many Nixos modules that expect some form of secret to be given to them, and they cannot take it as a hashed thing, right? So for user passwords, that's a thing, although it also says it's dangerous to do that in the documentation. But for like your restic backup password, for instance, you can't really do that. You have to make sure you don't end up with that password in your store one way or another. So the question is, with systemd secrets, is there a way to manage ownership? Not really. Like the way you do it is when you have a systemd unit, you tell that unit to load that encrypted secrets, and systemd mediates that access. So only that unit will have access to it. If you need it to be on disk somewhere, you basically create a unit that will copy it on disk. Like if you want it in your home directory or something, you'd create a unit that will copy it to your home directory. But that's not actually a very common use case unless you're talking about like Home Manager, which is a different area. Typically, you want secrets to be given to one of your daemons, right?
I don't see any more hands being raised. I'll assume there's no more questions left. And one more applause, please, for the speakers. And then I would like to invite Ryan on stage again, and the rest, please move off.
1, 2, 1, 2. Thank you everyone for attending all those talks. So here's the moment you've been waiting for, the lunch. So as always, I will be inviting you to go to the park where we'll be having lunch in the tent like yesterday. So due to what you've seen, like yesterday we had a great weather, right? But yesterday night it was raining a lot. So there is a lot of mud. So fortunately we have a hackerspace close to this venue. So we built some kind of bridge so that you can walk on it and don't have mud on your foot or your whatever, your shoes. Please be careful on the bridge, like it has been built very quickly. There are some holes in there, so please be careful. And yeah, this is a zero waste lunch. So if you have any reusable container, please put it aside for us. Otherwise, we will be charged up to 800 euros for that. So please help us on this. And otherwise than that, I invite you to go to the park. So either you can exit from here or you can exit from there. And come back at 1:15. I've been said.
Okay, if everybody could take their seat again, it's 1:30 sharp, so we're going to adhere to the schedule, and I'm going to let Tom speak, so thank you, Tom, very much for talking to us. And good luck with you. So can I please have an applause for Tom already?
All right, I can sing, I can dance, I can tell jokes. No. Okay, I think we're going to get started here. Hopefully everyone's well fed. Lunch was excellent. Yes, plenty of food. Okay. All right. Hello, everyone. I'm actually really excited to be here to see a lot of people for the first time. This has been an awesome experience so far. So I just kind of want to just say thank you, and it's been very exciting. All right. I'm going to talk about Phlox, kind of the what and the why. Can everyone hear me in the back? We're good? Okay. And so let's just jump into it. All right, I'm going to go through a little bit about like what the mission is. What is all this about? I'm going to go into a little bit of detail about like what Phlox actually is, and then go into some of the more like strategic things, like why are we doing it? Why are we making certain decisions? And some of that is trying to get to the telling of a story, trying to give us an idea of how do we go from where we are now to where we want to be, and then we'll take some questions at the end. All right, so I started out with Nix about almost a decade ago. I encountered it randomly while doing Haskell work, and then I realized this thing was amazing, became an instant fanatic, loved it. I started using it. I started having projects, I started using it as like an individual tool, started learning more and more about it, and kind of acquiring all those great superpowers. And then eventually I started having a chance to like introduce this to teams, started to bring into corporations, started to bring into teams that I had a little bit of technical control over. And every time I did this, I realized that Nix solved a lot of problems. A lot of the issues of like, oh, hey, my VM broke, I need to rebuild it from the README, I'll see you in 2 days sorts of problems went away. was able to travel the world and bring it to like planes and radios and do all sorts of crazy, amazing, wonderful things. Was able to like do like hardware in the loop testing and go do stuff I probably should not have done. But in the end, I had all these great outcomes. We had results and we delivered them fast. Except as soon as I'd leave, all that would be ripped out. You hand it off to some contractor and the first thing they do is like, oh, we can't understand this, boom, they'd rip it out. And so longevity, adoption, this was something I struggled with and it was really disheartening. It saddened me because I really wanted them to have these great things. I saw the value in it. It was hard for me as an individual to kind of get this thing adopted. So realizing that, I'm like, okay, how do I fix this? What can I do to do this? So I started kind of reaching out, getting more involved in community things, trying to figure out like what actually makes this ecosystem tick. Why does it work? Why is it effective? Why do I actually love it so much? Because if I can't figure it out for myself, how am I going to be able to tell the story to others? So reached out, tried to figure this out, and what I realized is that there's no silver bullet here, right? Okay, maybe that should have been obvious in retrospect, but there's no one thing that we can fix. There's a lot of things, there's a lot of efforts, and I can't do this alone. So that starts to kind of lead me down the path of like, well, how do we fix it? Hey, let's actually do this with some sort of like tell the end-to-end story of why people should care and how people can adopt. And then that starts leading to this being a bigger problem. Hey, who's working on this? Who's working on this full time, right? This is not going to be some sort of a side gig or like some sort of like hobby project on the side. Like we got to dedicate time and people to this at some sort of a scale. And that starts to imply, hey, let's start figuring out like, is there a company doing this? And so this talk is trying to kind of tell you about where we're going with that idea. All right, so what is Phlox? I want to go through an example of like what is the adoption flow and the difficulties people sometimes have during that adoption flow, and then go into a little bit about like, hey, how are we going to address problems at each step of that adoption flow? All right, I want to install Lix because someone told me about it. They said it was really cool. You know, they just won't shut up about it. Thanks. Okay, I go to install this thing. What's a single user install? What's a multi-user install? I have no idea. All right, I'm gonna go do something else, right? Or hey, how do I install this thing? Is there an easy way to install it? Let's go look at the docs. Uh-oh, right? Again, these things are improving, but this is an adoption hurdle. How do I install this into some like corporate environment where there's all these strict controls about what I can and can't install, and you want me to curl something down? Well, it's gonna be weird. So this is a hurdle. All right, first thing I want to do, great, I've heard about Nix packages, let's start using them. What's a channel? What's a flake? What are these branches? What are these releases things? Sometimes I want to like build some software, or I want to run some software, and I start like rebuilding core utils. Why? What's happening, right? Like we see this happening, all right, Control C, something went bad. But the new user is going to be just sitting there waiting for hours, and they're like, all right, this is worthless, and then they never come back. That's a problem. Hey, what's a profile? What's a shell? What are these environments? How am I supposed to use these things? Which use cases are they for? Again, you know, maybe you could eventually learn the nuances, the distinctions, but like, who's telling me exactly like what is the proper path? What should I use for my use case? Because I'm trying to solve XYZ problem. I don't really know. These are all very new to me. Great. Now I want to build my own packages. Like what's a Nix package is no longer enough. I got some custom thing and got something that no one cares about or it's proprietary. I need to bring it in. How do I do this? Uh-oh. Builders. There's 15 different builders. There's 7 different language Nix tools for my ecosystem. Which one do I use? What's the difference? How do I distinguish between them? How do I decide if I'm a newcomer? Again, pretty difficult. It requires expertise. All right. I was able to build everything. I'm good. Now what? How do I manage this artifact? Where do I put it? How do I cache it? What are the tools for this? How do I then, after this, how do I tell the world that I've done something awesome, right? And now we've got foobar 2.0 out. But how can I tell the world? How can I get this out to my users who might know even less than me about Nix? Uh-oh, problem. Now I want to do this in runtime. I now want to manage this over time. I want to kind of manage the life cycle of my containers, the place that this is deployed in. How do I do push-pull deployments? How do I do red-green deployments? What am I supposed to do here? There's all sorts of solutions, but like which one do I pick? What are the differences? Uh-oh.
So Phlox is trying to kind of look at this entire cycle. So there's no single thing that I want to trim it down to. It's more, let's tell the story end to end. So I'm just going to go through some of the things we're working on, not comprehensive, but just give you a flavor of the sorts of things we're doing to address those problems. So I'm installing stuff. Hey, let's have just native installers in the various ecosystems. Does it really matter? Maybe, maybe not. We can argue about the benefits of this, but if it's comfortable for someone who is from a particular ecosystem to just use their standard installation processes to just give Nix a try. All right, so let's have like native installers. It lowers the barrier to entry. It's nice. All right, now I'm accessing Nix packages, but half the time I'm rebuilding core utils. Well, sometimes I just want like a Nix packages where I know everything is there. It's built, it's cached. I just want to be able to bring things in. So we call this concept the catalog. And it's pretty much Nix packages, just with a promise. Everything in it is buildable and substitutable. Nice. And then on top of that, we can build access to semantic versions. I want foobar 1.5 today, but tomorrow I might want 1.4. Make that accessible to someone who's new. Like, yeah, I can go reach in there and go figure out which commit to grab and weave it into my expressions, but let's make this easier. All right, the whole problems with shells and environments, profiles, these are sometimes confusing and overlapping. All right, so let's take some of the best ideas from these things and try to kind of create a concept, right? Started with this idea of, well, we got profiles, they're useful, they're ad hoc, but then now I want to start sharing them. Well, if we make them declarative, I can serialize them somewhere, I can push them somewhere, I can share them and get reuse out of these things that otherwise would have to be imperatively managed and built up. And that makes them reusable. Sweet, that usually sounds like a good thing. Now I want to build my own things. Again, this is essentially the language to Nix problem is a portion of it, but also giving people a smooth introduction. Slowly start having these more templates. We're seeing a lot of efforts to improve this problem, but again, this is another area of interest to get better at. Now we start getting to maybe a newer concept, but I now have my artifact. What do I do with this thing? It's great that I have it, but what do I do with this? So let's start publishing these things. I want to tell the world, foobar 2.0 is out because it's great. You get all sorts of foo out of it. But how do I do so? So let's make that easy. Let's set a convention, let's set a standard on how we actually do this sort of thing so that over time, people benefit from the same thing I just did. And one nice thing here is, cool, once I publish something, that goes into that catalog. Great, now I've got a flywheel. I know how to produce, I know how to consume things others have produced for me. I know how to kind of add to that package set. And then now other people get that same great onboarding that I did, but now they're using my software. And that's always a good thing. All right, and then now I want to be able to I want to interact with runtime. All right, so let's make it easy to throw everything into a container. Let's make it easy to escape from the confines of the runtimes we might have and provide those escape hatches. How do I interact with my DevOps department? How do I provide useful reporting that people might want? How do I do distribution of compliance builds? These are the sorts of things that we want to start being able to provide. So that's a little bit about some of the details of the sorts of things we're working on, but why? Right? What's the strategy here? So larger scale adoption of this fundamental superpower that Nix represents, we have to tell the end-to-end story. I think the talk we had with Gunyam was great. You have to tell a story. You can't just say, here's a great feature, it's not going to be enough. Now, stories have a beginning, a middle, and an end. Right? I can't just tell you at the very end. I'll need to kind of take you on that journey. So I think that's what we need. And then the whole beginning, middle, end means that, well, there has to be an end. There has to be, again, a way for you to come into the ecosystem and also leave it. And that means if you try to do something that has a lot of lock-in, well, we're too small to make that sustainable. So you have to avoid that problem. How do we do that? I want to go into then categorization. So how do we think about this problem of how do we actually build a sustainable effort? And so we split this up, we call these the 4 C's. So there's community things. These are stuff like the health of the community, making sure that Nix is stable, make sure that it's a strong community. Because if it's not, then hey, then the fundamental things we're trying to build and give to our users is already shaky. So the efforts that have been run, the board kind of being revamped, having the stronger teams, investing a lot into some of the the Nix packages, making sure that's got improvements and has standardizations in there, making sure Nix itself has a better cycle. These are all things that are helpful and useful. The various like bugs and fixes are just things that are fundamental that help everyone. Cool, these go into the community bucket. Then we have things that are convenient. So, hey, I'm an individual developer. I like having tools. But as an individual, I don't want to start figuring out how to sign in here or sign in there or get nickel and diamond on this or that. Like, I just want convenience. Excellent. Well, that seems to be a very good candidate for the sorts of things that belong in open source. Then we start getting into collaboration. This is where you have multiple people working together. You're in a small project or a small company or a small team. You just want to be able to work together. Great. You need to have insights. You need to have a little bit of visibility into what's going on in the team. You all trust each other. You're all working on one coherent goal. Now we're starting to talk about things like there are services that we can start provide. Give you insights into your package sets. Give you insights into what you're doing with CI. Right? This is essentially what a lot of CI is. It's just improving collaboration, all the Git forges. Is it really improving on Git? Well, no, it's improving on collaboration. So these things go in the collaboration bucket. Now we get to the actually interesting part, because to make this sustainable, something's got to be monetizable. And that means organizations, companies, these are the bigger checks come from. And what do they want? One of the things they want, they want collaboration, they want all the convenient stuff, but what distinguishes them is they usually want control. They want to be able to set a policy, they want to be able to enforce policies, they want to set access controls. These are the sorts of things that they want. So those sorts of features, cool. That goes into the control bucket. That gives us some way to decide where something goes. And I want to end a little bit on this concept of the ladder, or the learning curve or something, but this is useful for me mentally, so I want to maybe try to infect some minds with it, and we can start using this as some terminology. So if I have to start the lowest rung of this ladder and jump to reach that top rung, I mean, I might get there, and if I can grab that top rung and get to the top of the learning curve, and I pull myself up and get to the top, great. That's a lot of fun. I now have the superpowers. It's great. Except I might not succeed. Right? I might jump and fail, or I don't feel like jumping that day, and boom, that adoption motion's gone. So this is the problems of a very steep learning curve. We could try to fix this a little bit, but again, there's no silver bullet, right? Because if you try to do one thing and to make it super easy, well, it might break, it might fail. You might end up having something that gets stuck halfway, and now you have nothing to stand on to make progress. So what do? All right, maybe I can make it a little bit easier. I build another rung of the ladder, make it easy to climb to that point, so now I can kind of reach that joy I want to reach. Well, still not perfect, but I could do a few things now. I can kind of maybe clearly describe what's at the top. This is the end of the story. Be able to shine a light on what are the benefits, not just telling you, hey, do X, Y, Z, but like explain why. You're doing it because you want to reach this joy, and I want to share that with you. There's a problem, or a potential problem here. What happens if I build these rungs, but now you're kind of blocked from getting any farther? Now I have a step stool. This doesn't lead to joy, this leads to sadness. Now I'm stuck. I can't move on. I can't learn more about all the great things, all the superpowers, right? These superpowers I want to make normal powers. So only simplifying or only hiding Nix, that's probably it's gonna lead to this situation. We'll have a step stool, but it's limited. I want to get access to the entire process. So that's the ladder. The ladder leads to happiness. It's where I want to be. It's where everyone has access to superpowers. But you can climb at your own pace. You don't have to jump up to the very top on day one just to understand how to do a double overlay adders thing to get your Python project in. No, let's make it easier. Let's slowly let you climb the ladder. And every time you take a step up, you get more value. So let's build this ladder. Let's build that value. Let's tell and support this story, because that's what actually leads to happiness.
We do have some time for questions, so any questions?
Thanks a lot. I really like this idea of adding on top of the open source ecosystem values, the values that are kind of, that only a company can do. This appears what Flux is doing. Do you have an idea, do you have a plan for where to put that boundary? So where does open source end and where does commercial stuff begin?
So the guiding principle for that is the 4 C's there, right? So if there's something that's convenience, that's probably something that's convenient for everyone. The services start coming in once you're in those things like collaboration, right? You can imagine having the sorts of collaborative features that you start getting with informing people about what it is they're doing across their various projects, right? This is very similar to existing efforts that are out there. But I think the interesting question is, what you asked is like, how do you then figure out, how do you actually draw that line? It's fuzzy, but I think on the very end of it, I think it's actually pretty clear that this notion of control, that's usually not going to be needed with that individual power user, that hobbyist, even that like super small team as they're starting up. The control things, that's really what you want at high, large organization level. And so I think that allows us to separate these so there's no conflict. Because obviously what you don't want is there to be this kind of conflict of what becomes open, what becomes closed, what do you sell, what do you monetize, what do you not, now what? So trying to distinguish these things by having like categorizations and a set of values and how do I decide these things helps us potentially avoid that problem. And forgot to mention, we've got proof of concepts of this thing, we've got a beta out, so sign up for these things, go to fluxdev.com, a little pitch here. And you'll probably get to hear from one of us to kind of like walk you through things or bug you with tons and tons of questions, because the whole point of this is to make it easy. And well, that requires a lot of work, a lot of feedback, a lot of talking to people. And let's make this happen.
Thank you. One more round of applause. So yes, while we get set up, how was lunch? You guys enjoyed it? Nice, thank you. Oh. Let me fix that.
Right now? Oof. I try again. Everything okay. Okay. And now? Is it better? Yeah.
Sorry for that inconvenience.
No.
Can you? That's because we both are on the stage and it's annoying. So if you can unmute yourself.
I mute?
So thank you for waiting. Ivan, can I have a round of applause for him, please? He'll be the next speaker.
So, hello everyone. It's a really small talk about my personal experience to build a REST project, package a REST project with Nix. I learned Nix not so long ago. I basically from the side of NixOS, I was really impressed by having like this my computer is one configuration file, and I can have rollback and all this thing, and so much cool tooling. And when I learn Nix, I don't really learn Nix first, and I take time before understanding really the Nix language, the Nix package construct. I could only advise anyone that's new to Nix to take time to understand that rather than just finding way to write overlay to find the right Nix OS option in the search. And really, Nix Pills is the best resource I personally find. I just want to say thanks to that. And also, Nix Pills helps to write basically an AutoTools derivation, explain how to rewrite the STDM make derivation thing. And so I start to wondering how to package stuff myself. So information on this talk come from NixOS Wiki mostly. So this is not the most up-to-date thing, but I think we should all contribute to make it better. And so when I started to wonder how to package a REST project, I found out there is a bunch of different solutions and was like, why there is no one canonical solution for that? Why so much? So I just really explain what is a REST project. It's a bunch of REST file with a configuration files that explain what are the dependencies and log files that give precise hash and version of array dependencies. So the question I ask myself about what's the difference between all these solutions are questions that arise every time you want to package a language project from a language or framework. And basically, these kind of questions that arise are the number of derivations that are produced by your the Nix solution you choose. And basically, the more simpler solution is to just build one big derivation from a project, which is actually simple to maintain because it's less Nix code, and it also should be more faster because it's less Nix plumbery or overhead, so it should be better. And the thing is, when you produce less derivation, you don't use the full caching power of Nixstore, which is to have, for example, incremental builds. Like if I just update one line in my source code, I don't want to rebuild all my full project. And I should want to share dependency between different projects, which is actually maybe not so much as things before content addressed derivation, but anyway. And here, when I speak about dependencies, I speak about the language package dependencies, like what is defined into cargo.ml, or if we are in Node, like what is defined in package.json. I do not speak about what I would call system dependencies, which is basically your build inputs, what's the system package on which you depend, like OpenSSL, curl, or this kind of stuff. And so the other question we find when we read README about things to help to package your project with Nix is about EFD, which is a word I discovered in the Nix jargon, which is basically a really handy feature of metaprogramming, which is if a derivation produces Nix code, I can import this Nix code, which is really useful because it helps you to don't write using Nix a lot of things which will be painful to be written in Nix itself. For example, often package manager use custom format to define declared dependencies, and writing a parser in Nix could be hard, and often like the only real specification of something is its own implementation. So in this case, it's hard to do an alternative implementation in Nix. So the thing is, all this solution shares the fact that promotes that don't use EFD. And what I show here is only things that still are maintained somehow. And the thing is, Nix package will not accept any PR of some things that rely too much on EFD, because there is a flaw which is it's quite of a performance bottleneck in the evaluation of your Nix expression if you rely on it, which is maybe a problem that will be finally solved in Nix itself. So the last thing I look at was what was the default coming from basically the flake or less flake approach. If I look in Nix package and find there is something defined which is Rust platform, will give me a build Rust package things, which is where are all the language framework. The link I give it, it's a bit hidden in the manual where there is all the per language instruction. And if I try to do with Flake, I was thinking the most canonical source of trust was the NixOS/templates repository, which uses NERSC by default, so it looks like a standard solution. I try to compare this solution, and basically, this package produces one big derivation and offer you to use hash to trust the reproducibility of the output of it, or to rely on cargo lock, in which we put trust to be a good source of determinism. And if we compare it with NERSC, NERSC does not produce one, but two derivation, which is really handy because it produces one for your source code and one for your dependencies set, which is useful because we should update more often our source code than the set and dependency on which it relies on. So if you update only the source code, you would just rebuild your source and not the set of your dependencies. And if you change the set of your dependencies, it will rebuild everything. And the last thing is cargo to Nix. And cargo to Nix uses a trick to not rely on EFD, which is to rather generate Nix expression not as a process of the build phase, but as a pre-build step, like I have a pre-build step to run to generate Nix code, and this Nix code, I will import it in my Nix framework, and that will produce one derivation per crate, which is a lot of derivation, and I don't know if it's overkill, but that's one alternative. And to conclude, the thing in which I put a lot of trust and hope is Dream2Nix, because it tried to offer what would be the best default solution for large amounts of language and put them behind some consistent API, that's the way I define a package, whatever the language. And Dream2Nix offer either to wrap Nix package, the Nix package solution, which is Rust platform, I should write that, or Crane. And Crane is like very close to NERSC, but offer better API as I understand it. I didn't take the time to reread the blog post before this talk, so I invite you to read it. Also, I want to highlight Riff, which is not about rebuilding a package, but which is about deriving a developer shell and guessing what's the right build inputs of your project from your language-specific dependency declaration, which is really handy and which is what most of users actually, I guess, want when it's not about publishing and things on Nix package, but rather having a reproducible developer environment. So that's all. Thank you for your attention.
Thank you, Ivan. Are there any questions? No questions? Yes questions? Okay, one more round of applause then, please. So, did somebody mute me? Somebody muted me. So our next speaker will be Graham, another pretty well-known name, I would say. So please give it up for Graham, a round of applause.
Hi. Sound good? Thanks for coming, everybody. Really wonderful to see everybody again. It's been so long. It's so good to see everybody in face and have these conversations in person that we just can't quite get the same thing online over video calls, over Discord. You know, it's so special. But I want to talk a little bit about something a little bit different today, which is the idea that, you know, maybe things are good enough, and maybe sometimes we're actually going a little bit too far. And I think it's really important to focus on why people really want to use Nix and what they're trying to get out of Nix. To start with, I haven't had any coffee today, which is a little weird. Haven't been in front of 200 people in a long time, so that's a little bit weird. But it's really nice to be here today. All right, let's talk about why people use Nix. Who uses Nix because of the sandbox? Is it the sandbox that you use Nix for? What? Sure. All right, how's that? Louder? All right, how's this? Even louder? Okay. All right, good. Okay, so the sandbox, some people say they use it for the sandbox. How about version pinning? Being able to pin Nix packages or their other dependencies, I use it for that too. I think that's a pretty sweet feature. How about reproducibility? It's kind of nice, right? You can run it on your computer, you can run it in CI, you can send it over to Luke and have Luke run it, and maybe it'll work there too, though he's on a Mac, so I'm not totally sure. How about software freedom? Anyone use Nix because of software freedom? This one's a little bit tricky. Like, what is it about Nix that gives you software freedoms? I believe it enhances software freedoms because it lets you patch anything in your entire system without any more effort than a simple overlay. Almost no package manager can do that, and Docker doesn't get close. And I think that's something we really need to appreciate as a free software community. But I think there also might be one other issue here, one other reason that a lot of us use Nix that we maybe aren't talking about yet, which is that it feels great, right? You get some piece of software and you're trying to make it work and you iterate and it fails and fails and fails and fails and you try and figure it out and finally it builds and maybe you even have a NixOS test and you get that clean result symlink in the end and oh my gosh, it's like, it just tickles all the right parts of the brain, right? And in so many ways, Nix is such a superpower, right? It lets us do things that almost nobody else can do without Herculean effort. But sometimes it takes that Herculean effort to do it with Nix. And in those cases, it's not actually a superpower. In many cases, it's actually getting in the way. If you're doing JavaScript development, a lot of chuckles. Maybe you're using some test framework that downloads Chromium from the internet. Yeah, those aren't so fun, is it? And what do? Do you fix it? Do you suffer? Do you keep hammering on this build to get it to work? You might. But one of the things about this is that, like, as a community, we have it in our minds that the ultimate goal is to get it to build with Nix. You know, distribute, get to that closure, build it with Nix, get that closure, get it out on NixOS. You get so many cool superpowers if you can do that. But the truth is, this is a bit of a diagram I call the zones of control. The truth is that if you stay up on Nix run, how much of the value of Nix do you get out of it? A lot. You can install Nix on a Mac, on a Linux, you can get JQ or lolcat or a bunch of Pythons and all these different environments, right? And you can get all of that for basically zero work. And I think that's incredible. And you don't have to give anything up for that. Nix doesn't get in the way. It doesn't mess you up by default. Everything is easy and good. And so maybe you take the next step. So you've had such a good experience, but easy so far, and you go and you make a flake.nix and set up all your development tools and make those all available in a dev shell. And that's really cool, right? That takes you from maybe 80% to like 90% of the value here. Because you can take that flake.nix and use it in CI. You can share it with your colleagues. You can shorten the onboarding time for a new employee from like, a death march of 2 weeks down to like, oh, just install Nix and run Nix develop and you've got everything you want. That's super cool. But, the next step here is building with Nix. And actually to do the flake.nix, you had to learn something, right? You had to learn the expression language, you had to learn how to find packages, you had to, figure out make shell, you had to figure out all these little pieces. And that's okay. It's good to expect people to learn things, no problem. But once you get to the Nix build, you start to get to rules. Rules that I quite like. Rules like you can't talk to the internet unless you know what you're getting. And you can't write to just random places on the file system or read from various places. And you can't do a caching build, right? If you do a build and change one line of code and do a build again, you're paying that whole compilation cost again. And that's a big cost. And I think we need to remember that's a big cost. Some tools, some projects I've seen, there is no support for building it outside of Nix build. And so the iteration time is very slow. But if it takes 30 seconds, I'm out. I'm gonna go read Twitter and watch some YouTube videos. I mean, just to be honest, that's just who I am. I'm gonna do that. And so actually, what we have here is I sort of show a funnel of the zone of control, how much control Nix has over the overall environment. But if we think about new users coming in, the funnel is the other way, right? It's very easy to get started with Nix Run. Anybody can go do that and feel successful. Almost anybody in that group can go write a flake.nix from copying it from another Go project and make it work. But it gets mighty sharp, mighty thin at that Nix build step. A lot of software works there, but some doesn't. And how, like, if some of your software does and some of your software doesn't, why are you going to bother moving on? And I don't mean to chastise us for having these rules. Like, these rules are critical. We can't give them up. Especially within Nix packages, we can't give them up. And that's because so often as a community, we're building software that is at the core, right? And so by being at the core, it's really important that we maintain these principles of purity and reproducibility in the sandbox. But I think we're at an inflection point as a project. I think we're at a point where we could be finding whole new communities of people that are happy with Nix if we're willing to welcome them to the project. And some of them, I wager, they don't need all these rules. If you're making a JavaScript website and you're pushing out your JavaScript website, you have no use for the closure. You're pushing it up to a CDN or something. You're going to be substituting from Fastly or Cloudflare or something. The primitives that Nix offers are less effective, less important. And I think if we find a way to be more approachable as a project, as a build tool for these tools that are very difficult to build with Nix, I think we could get some really nice engagement, nice interaction, nice collaboration between these communities. Imagine if instead of telling JavaScript projects, sorry, they're really hard to build with Nix because they just don't play well with Nix. Imagine if we found a way for us to work together somehow, and then they decided on their own that they wanted the properties of Nix, right? I think that's a really interesting idea. And I'd like to invite those communities in. I'd like to sort of be big tent here. Like, how do we get these communities who are solving problems for the users to embrace these ideas of the reproducibility and the purity and collaborate with us on a way to do this? And I think it's good. I think if we can do that, that's good. Because if you get down to a closure, you can do pretty neat things. You can export to a Docker or container. Antoine's talk was fantastic. I actually deleted a bunch of slides because he just did what I was going to say I want it to happen. Amazing, thank you. And then if you can get to NixOS, like, I don't know, I think these are super cool, really powerful, and I don't want to give them up. But at the same time, we, as Nix developers, we tend to have this sort of ICE9 mentality, that you get a little bit of Nix somewhere, and then you want to write Nix to do this, and a little bit more Nix to do that, and a little bit more Nix to do that, and it just spreads and spreads and spreads, and then all of a sudden you're writing Terraform code in Nix, and your colleagues are looking at you like, what the heck is going on? Why are you writing Terraform in Nix? I don't want anything to do with that. And I don't know, there's actually an argument in favor of that. The Terraform language is a little bit weak as a language on purpose, and Nix is a powerful language, but I think being like, having tools that look friendly, look familiar, that people can share and understand from where they're coming from, I think that's important. And I guess what I'm trying to say here is once we reach the edges, once we get out of Bootstrap, once we get out of Nix packages, once we're actually talking about software we're deploying ourselves somewhere, I think it's okay to get creative. And I think it's okay to get creative in ways that maybe doesn't belong in Nix packages, but it doesn't, that's okay. Like, it doesn't need to be in Nix packages. And so probably the spiciest one here is, you know what? I think some people should turn off the sandbox. And I think it's okay. I think if your JavaScript application is downloading Chromium for a test phase, I don't care. It doesn't bother me. Probably doesn't bother you. And you want your tools to work well. I think that's cool. I think it's good. I think if you can build it with Nix, even if there's a little bit of impurity there, I think that's good. I'm not the only person to say this. Jonas, where are you? Maybe he's hiding. I don't know. I might be hiding after this. And I think there's other opportunities here. We do some funny stuff in Nix packages. We have all these really great tools for building Docker images. So this is the part I deleted. Wouldn't it be great if we could, not rebuild all these Docker layers on every single build and just figure out what we need to build and upload at build time? But it requires doing something out of the sandbox. And as Nix developers, it's very tempting to say, oh, we have this great execution environment. It cleans up after itself. It manages all its dependencies. It's so nice. We can, hack it out in some dirty bash in a few minutes, and it's okay. But by spending a little bit of time on this, Anton was able to make a tool that instead of taking 30 seconds per build, takes on the order of seconds. Man, how cool is that? 30 seconds is my limit. 30 seconds, I'm out. I'm back on Twitter, like I said. And that's not a joke. Genuinely not a joke. So another example here, something we've experimented with and actually use on the Foundations infrastructure. Nix netboot serve, if you've ever built a netboot image from the tools in Nix packages, 10 minutes, 15 minutes or more. You take a closure, you put in a squashfs, you put the squashfs in a CPIO, you copy all this data around. If you're remote building, it's even worse because you have to upload it and download it, and oh man, it takes forever. But the thing is that like the very next thing you're going to do with this netboot image is you're going to throw it up on a Pixie server and you're going to boot it. That's not Nix. Who cares if you're using Nix to actually make that image if you have a good tool to do it? You could instead take, and that's what this tool does, is it takes every store path, turns it into a CPIO, and smushes them all together. The rebuild times are like 1 second. And that's cool. Like, I think we should be really embracing this concept. Nix to container. Again, I just can't say enough how much I appreciate the existence of Nix container. Something that we've been experimenting with internally is this idea of ephemera, of what if we could build NixOS images that if you rebooted, everything was erased, like, really take the purity all the way. And we've been able to build NixOS images in seconds, sometimes less than a second. It just takes a little bit of creativity. Like, what are the principles of these immutable, these non-interfering store paths that are isolated and individual, and you can process them one path at a time and reuse that processing later on. Basically, all of that secondary is I/O because it's just like catting a bunch of files together. And so, where else can we get creative? I mean, I think there are a number of places we could get creative here, and I think we need to be creative in ways that are good enough. For example, the Dream to Nix tools that are looking at lock files and very creatively trying to find all the dependencies that are needed to build it. But maybe they don't build in the strict sandbox, but they probably should, even though they are impure. I think that's okay. I think that's good enough. Things like flakes. There's a lot of, are flakes good enough? Well, I'm open to discussion here. I'm not saying anything here, but I think they are good enough. And what I found is that people can learn flakes in a way that they can't engage with the regular Nix stuff. Like it gives them a thing that they can copy and paste and they know what they have and it's a concept they can learn. And other ways that we can be taking the closures that we have and be pushing them to somewhere else where they're actually doing something, right? What's the point of Nix and NixOS if it's all inert? If it's all pure, well, it's not really the point. So how do we get from this position where we are regularly making tools that inject, sometimes many tens of minutes into our iteration process, and how do we cut all of that out and make it a fast, good experience, which people want to get to, right? How do we say, okay, yeah, 80% of the value is at Nix run, 85, whatever is at Nix develop. But if you can get all the way down to a deployed closure, you could be testing like you're in production every second. That'd be a thing. That'd be really exciting. And I guess overall, I just want to say, Nix has been here 20 years, just about. I guess 20 years next February. Why are 200 people here? It's because for 20 years, people have been seeing this idea and saying, all right, well, that's amazing, but what if? What if it did this extra little bit? What if we made an operating system out of it? That's nuts. I think if you asked anybody at the time, that was nuts. Even Debian's coming around to some of these ideas. So let's keep going, let's keep pushing this boundaries, but also consider if taking a single step back from where we are could do something especially cool and especially powerful. Thanks.
Thank you, Graham. Are there any questions?
So personally, I'll keep my pure builds, but if we do want to do the kind of, I feel like it's a wine approach of you make people bring Windows games to Linux and then they do the native stuff. Like if we bring JavaScript people in with impure and no sandbox, then hopefully it will get better. But do you see that as possible while you need to restart the daemon to make it not be sandboxed?
Cool. Yeah, so is it possible to do this when you have to restart the daemon to support unsandbox? So I'm on board with that. I like keeping my pure store. But also, if you relax the sandbox, it doesn't automatically turn it off. You have to opt into it. And in general, most of my software is built on Hydra, right? So I'm not actually responsible for that remaining, well, it's complicated, but my personal machine is not responsible for that remaining pure. And so I guess I don't feel like you would need to restart the daemon. I think it would be okay to relax the sandbox and then have those derivations opt in. And another thing on that point though is I think by bringing these communities like JavaScript developers are incredibly smart. There's loads of incredibly smart JavaScript developers. And I think if we can give them, get them started and get them on the path, I think they might want to come back, and meet in the middle here if we give them the chance.
Hey, thanks you for the talk. So I'm curious, do you see Nix evolving in a direction where you have a more progressive story for people to start with less restriction, maybe? And as they go further with Nix, they can start having more multicity, more sandboxing, more stuff like that, which kind of reverses then the current story, because the current story is just, oh, you're trying Nix? Oh, you can't do that, you can't do that, you can't do that, you can't do that.
Yeah. Okay, so the question is, start moving the policy to be more relaxed and moving stricter? Is that what I'm thinking? Not necessarily, but I think it's good to stay relatively strict. But perhaps we could imagine an environment that says, oh, you tried to talk to the internet, you could try to fix it, but also you might relax the sandbox, right? It's sort of this whole spectrum of like, how pure are you, ultimately pure, and like ultimately nasty and dirty, and like I think many places on that spectrum are okay. But I think we should, especially in the core, we should stay strict, and then make it possible to get out and not shun people for that.
Thanks a lot. I think that was a great talk, and it's also a great vision of how we can get more people using Nix. I suppose as a leader of determinant systems, you're also wearing two hats. So I know for a fact you're like the Nix enthusiast. But as determinant systems, what do you see as your what are you up to? What are you up to? What do you see your place to be in the ecosystem? Because you're upstreaming all of the stuff that you're doing, which is great, which helps everyone gets their stuff done. You're showing these projects that you're developing on the open. What are you up to?
Yeah, great question. Well, so fundamentally, I think so I think a few things. So one is if we try to go make a big business today, we have 200 people in a conference, which is amazing and lovely, and I'm really proud of that growth, but I don't think it's big enough. And so what I think in order for it to really make sense, the number of people using Nix needs to be much larger. And so really our focus right now is how do we get more people using Nix, free, open, the overall ecosystem. Later on, I think it's sort of in the air that there's a lot of challenges around collaboration, and that's something we're working on.
Let's hear it one more time for Graham, please.
Because that one's acting up a little bit, I've noticed. Sorry for that. Yeah, you can stop saying that. I'm sorry about that.
That's okay.
Leandro. Yeah, don't worry about it. Okay, yeah.
So our next speaker.
Yes.
Hello? Could we please give it up for our next speaker as well, which is going to be Leandro.
Are we good now? Can you hear me? Anyone hear me? Like in the background as well? Okay. Well, welcome everyone. I would like to say thank you for your attention and your time. I'm Leandro, and today I want to present you not as much of a talk as other talks that we had today, but rather more like a testimonial or like a tale, right? About our experience with Nix at the work, right? So we've been using Nix as a part of our satellite development. So we at Aurora develop satellite payloads, and these payloads, their focus is to monitor the Earth from space, right? So basically, the idea here is that there's just this basically shoe-sized box that we get to space, right? And then just we never had access to it again. So you use it to like take pictures like this, for example. Now, you may wonder, what the fuck is that on the left, right? Or the right in your case, right? That's actually Paris, just that, yeah, it was quite cloudy. So I'm sorry I couldn't get any clearer pictures from our satellite, but on the right, you can see another example that I found within our archives. I'm not going to even try to pronounce that city, but yeah. So, but the thing is, this is about our Forest One payload. Our Forest One payload was pretty much done by the time I joined the company, right? So that's sort of where I come in, right? Joined the company about a year ago, and they had this sort of, let's call it a well-intentioned script to build a Debian system where you just put everything together into a makefile and you just get some sort of Debian image. But it wasn't really like really expandable, right? It's just you get only a very basic system which requires a lot of manual processing. You got every time you have to update the satellite, you have to manually connect to it, like send the shell script or set the packages, ensure that everything works, and you cannot fuck up basically, because if you can fuck up an update in space, you are pretty much screwed. So here is what we started to envision. We needed something that allows us to have more confidence on our own update process and our own software that are going to push into space. So this is just our first idea, right? Just, okay, what is the most basic concept that we need to get from this? Is just develop things, have them somehow get built into an image that we can trust is reproducible, then we can test it on ground first, and then we can create an exact copy on space. But we cannot be sending like an entire image on space each time. So we had to find some way to make that work into more reliable, but also small, something that can be done in small chunks. So here is where the idea of Nix comes into the picture, right? So we started to go down that rabbit hole of Nix. Just, okay, yes, we can start using Nix, but why not like just NixOS for like, if you're going to use Nix on space, just might as well, right? And then like we're also like starting to consider flakes as well. And this is the thing that very rough plan started to get into a more and more Nix-centered approach. And actually, that's like basically how I got hired, actually, because it wasn't my idea. Basically, it was the senior developer's idea. So like he heard about this Nix thing, and in the interview, like, you know, as you usually do, is just like, oh, hello, I'm Leandro. Have you heard about like Aurora Cyber Nix? And that landed the job interview for some reason. So we started like put it into place. And I started like actually developing the whole thing around Nix. Call me crazy, you would write, definitely. But I wanted to show you just like how every single piece of my diagram quickly became like infected with Nix pretty much. So yes, so the process started like a developer. They started to use like Nix on their own computers. They started to package stuff with flakes. Then they can proceed to build their own images. These images themselves are flakes, but they're custom stuff that I've had to hack around because, well, they're running on Jetson Nanos, no, not Nanos, Jetson Saviors, which are pretty much non-supported. So I had to hack around like the kernel and make it work. But then they are built on it's called dedicated builder. So one of the features that Nix provides you is just, I'm not going to build it on my computer. I can build it on a dedicated server or like machine. It can be, in our case, it's just a Raspberry Pi, but you can delegate that into another system. And the great idea about that is that Jetsons are ARM devices. So you don't have to worry about now any cross-compiling or having to SSH into a machine and that is ARM-based so that you can have a native binary or anything just transparently. Just Nix built on your computer and just, if it's configured properly, just knows to go to that server and just get everything built. Then, after that, the whole process is done, you can just trigger the pipeline. Just, again, that pipeline is going to be using Nix. It's going to use the same processes as well. So you don't even need to rebuild it again because it's already cached into your build server. But then we're also going to cache it as well, so we can share it like between different build servers. The pipeline knows like which build server was used, so that like because we have a couple of them, it will know to find the correct build server so that it doesn't have to rebuild again, and then put it into the cache so that all build servers have access to it. And then it will automatically take that that binary and just, not a binary, that image, all its updates, and just like send the corresponding like Nix store packages to a ground satellite replica, which is basically just a Jetson Nano with some hardware around it that's used for testing purposes. And that allows us to just do some proper testing. Like a lot of manual processes like go usually into testing, but that allows us to ensure that we can trust our software, like it boots, it doesn't break, not just like it doesn't break our software, but like just like all our services are working. The hardware itself works as expected because we have like custom hardware, so it requires custom kernel modules and all that sort of thing. And once we have that trust, that trust on the test software that we tested, we can just straight up push it to space through the same pipeline. This is like a dotted line because this is expecting a manual input, has to manually be approved. And then we can just push it straight to space. And we know that it's going to be an exact copy of what we had on ground and not have to worry about any statefulness or anything, just gets immediately pushed and starts running again, not worries over there. And as I've said before, everything in that's like using Nix in the background, and except for the developers, at least yet I haven't found a way to like get the developers running on Nix itself. But yeah, one of the many key points that I wanted to like highlight specifically, like reproducibility. As I said, it is a very important topic for testing on ground. We need to be able to have as identical as possible on ground compared to space. remote builders. Those, as I said, we need to have ARM binaries and not we don't have ARM computers ourselves. So that allows us to transfer bin things. The cache splits up. We have a lot of really big stuff that we need to build that can take quite a while, and that cache allows us to save a lot of time, specifically because we also have like an ARM7 processor. And I don't know if you've ever tried to build ARM7 stuff, but pretty much tries to build a lot of stuff from source. So that can save up days of building time. Then the ability to just package it into closures and being able to send it to like another system, so you can share stuff within systems. That this allows us to do a custom upload process because connection within a satellite and ground is not stable, it's not trustworthy. So you have to like split it up into small pieces and slowly trickle it over in space until you can get the whole thing over. And then you have to put it all together back in space and just continue as if like you just used for a Nix copy closure. And then the generations is also something that we found really useful because no matter how much you test stuff, there is a very high probability that something at some point is going to go wrong. And as I said, you cannot have any problems in space, right? So the thing is that it gives you that confidence that even if I fail at testing something on ground, even if I accidentally push something that I shouldn't have or whatever, I can always go back and just roll back the configuration and not have to worry about it too much. And it also, that generation thing is, I don't have to have two copies in space of the same image, for example. It's just have a single image with all the paths in the store, and then you just pretty much just switch to whichever path you're pointing to, and that's just changing the generation. So it saves us also a lot in like space storage. That it's really valuable in space. So honestly, between like how nervous I am because this is my first talk, I went a little bit too fast, I think. I'm sorry about that. But yes, I want to open up for questions. Like I give you some example questions here, but you can ask me about anything here.
Give him a round of applause. So are there any questions? My apologies for the ringing. I'm trying to figure it out. But are there questions? No? No questions? No hands? Am I missing some? Ah, there we go.
So if there's a problem, you mentioned generations. Do you like SSH to the machine and then just like pick the other generation? Is there anything to help if you completely bust it and you need to like reboot the system? Can you go into that, or would that be too much detail?
No, that's fine. So basically, there is beyond like there's an automated process. If it completely fails to boot up, that's going to be automatically rolled back. But if it boots up but something goes wrong, you don't like have quite often. It's not an SSH session per se. It's more like a bus like connected to a serial console that's using some weird proprietary stuff to connect to ground, and we just get access to that. So it's a SSH but more steps basically.
Any other questions?
Just more of a practical curiosity. How did you uninstall Debian on the satellite and then get NixOS running?
Oh, maybe I wasn't clear about that. This is our next payload that we're going to be deploying. So we deployed our first satellite, right? First one. But then from Forest 2 on, we're planning to use NixOS on it. So I may be lying a little bit with the title because it's not yet on Space. It's going to be in a couple of months. But yes, no, we're not updating stuff, or Debian stuff in Space. That we don't touch.
We do have time for more, so if there's questions, please raise your hand and I'll come. No? Okay, then one more round of applause, please. Thank you.
Just wanted to mention, thanks again for your time, but we're hiring just if you're curious about it, you can check on that website or you can ask me around. I will probably be at the hiring happy hour. So feel free also to come around. And thank you.
So we can have a break now. We expect you to be back at about around 3:20, and then we'll have one more talk. And then the hiring happy hour, right? It's happy hour without alcohol, but just try and mingle, try and chat, try and get to meet people, make some connections, have some fun, okay? And then come back for the closing ceremony. I'm told there's still t-shirts and coffee cups left, and that's unacceptable. Please come grab some if you want some. Could everybody go back to their seats, please? We are about to start again. I will start without warning this time.
Hey.
Could everybody please head back to their seats? Thank you very much.
I'll keep it on. 1, 2, 3.
Do I feedback? Can anybody hear me like this? Is it loud enough? Louder? Yeah. How's that? Louder or is it good? Okay.
Test again. Wait. Oh, I can hear myself. Okay, I'm gonna turn your camera.
Okay, how are we all doing? Is everybody enjoying it so far? Nice, nice, cool. So, we have one more talk left. One last speaker, one last time, everything about Nix. Here on the podium, I'd like to welcome Valentin on stage, and please give him a nice round of applause. I have to tell from Ron, I'm instructed by Ron, Valentin likes hard questions. So please do ask hard questions at the end.
Hard questions are the best ones.
Good luck.
So, okay, first of all, don't worry about the slides if you don't see them well or anything. There's not really much to see about them. They're just for illustration, nothing really to understand. I'll still upload them to the internet if anyone cares. So, okay, I'm Valentin. I was also already introduced. I'm really happy to be here today. The obligatory, how did I get to Nix? It was 5 years ago when I read Elko's PhD thesis. And it was like a revelation to me. I was like, why didn't we have that thing all along? Or something like that. It solved so many problems with building software such that we can finally forget about them. And back then I would never have thought to be like in the middle of this community who made this happen among all these great people who enable Nix every day. And yet I'm here now and will present to you what we've done about documentation in the past half year. And that would haven't been possible without Tweak. I'm really thankful that that I can be here today and having worked on these things. So I'll share with you what we've been up to. We'll briefly go over what everybody knows already. I'll show what we've been doing about it. I'll propose what I think we should do next as a documentation team, and if you agree, what you can do to help us get there, closer to that vision. So if Nix is known for anything except reproducibility on all the cool things, it's the learning curve. And that already starts at the very beginning. So there's no real overview, no real explanation what Nix is or does exactly. And if you try to look for one, you'll present it with a wall of text. And even that wall of text is, well, just another list of features. And we're really good at like telling how cool Nix is and what it does, but that's not real explanation. And it turns out eventually people don't even like to read all that much, and they also don't really care how it works as long as it does. So you'll all agree it's way more fun to play with something to get the hang of it. So we start with the tutorials, and the first steps are innocent, right? Run Nix shell. And that's what gets people hyped about Nix. And they really, oh my God, this is like magic, I want more of that. And even setting up a Python development environment is so manageable. I mean, if you know or care about Python. And if you don't and want to use a language such as Haskell, which is really well supported by the Nix ecosystem, which I just recently learned was also due to Tweak, well, you're presented with another wall of text. And maybe now you kind of get this idea of this learning curve thing. Well, you would have to read through all of that to even understand what the hell is going on. And at this point where these tutorials and guides start to fail us, we'd usually fall back to the reference documentation, like look at the real thing, right? But newcomers usually don't find it. It's so far hidden below the fold that they don't see it. And even Google search doesn't help. Like web search, it's no use because the pages are so large, they're ranked way down by search engines or not even indexed at all. And what inevitably follows is what people refer to as tab explosion or mental Stack Overflow. It does get the job done eventually, but let's be honest, it's a lot of pain. So all of us here obviously stuck around long enough to overcome that hurdle, to learn all these little tricks and details. And I suppose it's called expert blind spot. We forgot how we got there. I would say we actually erased it from our memories like a trauma, you know. And eventually people do reach the manuals somehow. And then they find that they're incomplete. So here's an example from the Nix language. I've compared all the major Nix language tutorials to see which language features they actually talk about, which they present. And on the left is the manual, the reference documentation for the Nix language. And it has gaps. So no wonder people get confused about things, because it's really hard to find the right information. So none of this is news, I hope, or unfortunately. What have we done about this? So the first step was to get an overview of the situation. There's this thing called diataxis. It's a framework for structuring technical documentation. I won't go into detail about this. We'll go over it practically. The point is it allows looking at documentation from the perspective of users' needs. Given a piece of documentation, what kind of problem does it help solve for the user? So I made a little survey of what's out there for Nix, and I categorized it both by this diataxis categories and also for each component in the ecosystem. And of course, that's incomplete, but it's just supposed to give us a rough overview of what's the state of affairs. And we already observe a few things very quickly. So all of the major ecosystem components, Nix, the Nix language, Nix packages, and NixOS have reference documentation. That's already good. But as we've seen, it's full of holes. And because it was the only documentation that we had for the longest time, it also tried to solve all these user problems at once, being not really good at any of them. The how-to guides, it looks like there are quite a bunch of them, but the point of the guides is to lead users step by step to solutions for their problems. So essentially, they represent use cases. And obviously, Nix packages and NixOS do many, many things. So if you put that into perspective, it's way too few of them. The tutorials are supposed to teach the skills that are needed for users to solve problems on their own. And there are multiple Nix language tutorials out there. So we've seen a few in this overview. But if you look at them closer, they're not really effective of teaching people these skills. At the very least, they don't set expectations what people are supposed to know when they finish them. So, and if you ever develop stuff in Nix package or NixOS, you will also agree that there's lots of skills that you actually need to get productive. Even simple things such as navigating the code base, knowing where to find what, these idioms and patterns that you have to learn, this whole software development workflow outside of the regular software development workflow. So we simply don't have enough tutorials to get people up to speed quickly. And for explanation, so the point of this explanation category is to provide more context, to give an opportunity to understand certain concepts better. And we notice here that it's really thin on sources. It's mostly based on Elko's PhD thesis, which I think is excellent writing. I even think it's the best writing that we have in Nix documentation. But it's a PDF. It's not maintained. It's, in a sense, out of date because the ecosystem has grown so large. And it only, it does a lot of things, and it covers only, a small part of it is only covering this whole background and contextual stuff. So that's what I intuitively focus on first. I saw this gap, so why don't we fill it with explanations? So it happened at that time, it was like in April 2022, that John Erickson set out to document Nix documentation, to document Nix architecture. And I was around, and so I sat down and listened to him like explaining how Nix works internally. And after a few sessions, we boiled that down to a bunch of diagrams and textual descriptions. We compiled a little table of terms used in different build systems, which mean the same thing, so that people can reuse their existing knowledge. I've made a little overview of concepts in the Nix source, such that people can learn them in a nice order. And unfortunately, still none of that is merged in the Nix manual, but hopefully we'll get there soon. But the point is, it got the ball rolling. And I started talking to more people about documentation and learning things. And eventually, someone put forward the idea, well, why don't you apply for this tweak internal project thing? And I did. And I got funding to essentially work on Nix documentation for quite a while as my job in a more organized fashion and do something about it. So at that point, that was in May, I already had an overview. And the next thing I came up with was the following idea. What if we had something like a journey into Nix, like a curriculum, the list of things that you would have to learn in a certain order to get into Nix very quickly and effectively? And the bulk of the required material, which is like getting familiar with the shell and learning a bit of the Nix language and then going into declarative environments and all these things, and only eventually go really deep into the software development lifecycle using Nix. So the bulk of the material is already present on nix.dev and the NixOS wiki, if you're familiar with any of that. And of course, it would make sense to reuse as much of that as possible and just rearrange it in a certain way. So quite naturally, I asked Domin, the author of nix.dev, and Jörg, who's one of the maintainers of the NixOS wiki, to sit down and see how we can collaborate. And pretty quickly, we thought about, in all seriousness, about forming a Nix documentation team to work on these issues. And fortunately, we agreed that we should collaborate and not step on each other's feet. Immediately, the question arose, so if we want to get closer to that vision, what are the first immediate steps that we have to do? What kind of immediate problems do we have to solve to get there? You cannot get there all at once, right? So you have to do some small incremental steps. And now that I had the time to go about it more systematically, I took a look at those infamous community survey results that Ron talked about multiple times. They're really valuable, and simply to find out what would be something that helped people most with the least amount of effort. And yes, one of the key things is that most people in Nix, like more than a third of them actually, are new to Nix. So if you look at that specific directly, it doesn't really matter here, is that almost half of the community is using Nix for less than 3 years. And you have to consider that it takes 1 to 3 years to get proficient in Nix. So effectively, almost half of the users that we currently have that were answering this survey either are factually newcomers, beginners, or feel like beginners. But what kind of problems do they have? That doesn't really emerge from this data. I sat down with actual beginners. So I observed 10 of them, people who used Nix for the first time or were in the early stages of using Nix or learning Nix, and that revealed some very concrete issues. These have been talked about a lot, and I tried to represent them in this little overview in the beginning. But that was very, very concrete. It was like on point, a list of things that we can immediately fix. And so I brought these results up in the documentation team. We discussed them and looked at this whole big picture, and 3 major patterns emerged from this. People have problems with naming, with flakes, and the Nix language. So naming things like, why is everything called Nix? Nix language, Nix packages, like, what's the difference even? So we can do something about that, like we wrote down the definitions and put them in a fairly visible place. We still have to make it more visible. But it's also questions like, what's an official project in the Nix ecosystem? Where do I get reliable information that I can trust? For flakes, people wonder, what is it even about? How do they help me? Should I learn them? Should I adopt them? Will they stick around? And how long will it take until they're stable? We cannot do much about this without getting involved into like high-level project leadership or marketing, all that stuff that would be out of scope for the documentation team. But we could do something about the Nix language. We could introduce people systematically to it, and that's what we did. And in fact, writing a Nix language tutorial would remove a major roadblock of getting into the Nix ecosystem. Because as you see from this journey into Nix, it's like a choking point into the rest of the stuff. And this graph is not even representative, so it's really abbreviated to the end. The lower half would be like 10 times the size. Just the NixOS part would fill the entire screen if you broke it down. So it's kind of a core thing that will actually unblock a lot of people. And well, after 2 months of writing and rewriting and reviewing and testing it with a bunch of users, we finally merged the thing a couple of weeks ago, and now it's on NixDev. At this point, I would like to thank Sylvan for his awesome reviews, who made sure that the thing is technically correct, the best kind of correct. And as Domin uses to say, and I agree, the only thing worse than missing documentation is incorrect documentation. We have to work on that a lot. But it's also not pulled out of thin air. It's based on the 2019 NixCon lecture by Jonas Chevalier and the Nix language one-page overview by Vincent Amble. So thank you both for laying the groundwork that enabled this. And what I think we achieved is quite substantial, because already the user testing and feedback shows that it does help users get into Nix more quickly, and time will tell how that's influenced uptake. So that's not the only thing we did, obviously. We helped merge a bunch of large and small pull requests, made lots of small changes to the manuals, which hopefully will help people get onboarded more quickly to reduce this initial confusion. We discussed various little details. And this list is growing and growing and growing all the time. And I think by now it's spiraling out of control. And I think now we should go a bit more strategic about these things. So we need a vision for the future. Well, we need at least to answer the question, what are the high-level goals that we should at least be aware of before jumping on to the next thing, such as we did with the Nix language tutorial. But that was really obvious. How do we even reliably identify what's a valuable goal to achieve? What to work on next? So I have a proposal for documentation. For each quadrant in this documentation framework, let us define what we want to strive for. I won't go into explanation, but for reference, we of course want it to be complete, correct, and easy to update. Guides should cover all the major use cases. We of course first have identified them and make a small set of them that we want to focus on first. And tutorials should teach all the key skills that we expect from people to be self-sufficient in the Nix ecosystem. And that should take a minimal effort from the learners. The whole thing should be versioned in lockstep with the software that we're documenting. We're still quite far away from that. And each of these areas should have a dedicated maintainer, a person that can keep coherence, someone who can take off the respective pull requests and essentially know the whole thing by heart to tell people where to put what. And we don't have such a person yet because the material is just too much. So I hope that we can agree that these are worthwhile goals to pursue, at least roughly. But this is still another wish list. We're really good at writing wish lists, but you have to act on them at some point. And how do we go about that? Well, we can't stop the world, I think, and just go off for a year working on reference documentation, updated tooling, all that stuff, because life goes on. As we speak, new users are joining the Nix party, people making pull requests that we have to take care of, and the code itself evolves, so we need to cater to many different needs and probably all at the same time. So what do we start with first? I suggest we do what Nix does best, something that Nix taught us to do well, declare dependencies explicitly. Here's an example how we could do that for reference documentation, just one part. It should be complete, correct, and easy to update. But what do we have to do to get there? So one example would be document all the exported functions with examples, type annotations. Examples should be tested automatically, and other stuff should be done automatically to also ease use of updating, such that user errors don't sneak in. And documentation should be easy to find, such as it's easy to update, and it should be documented how to actually work with it. There's more things that we can do, but especially we have to do more things to even get there. And if you look at the big picture, which is quite large already, and still incomplete, so I came up with this graph like in half an hour and just spent the rest of the time arranging it nicely. If you break it down in more detail, it will be 3 times as large or maybe more. But what we see that there are some tasks that many others depend on, the red boxes. And what if we focus on only these and say no to everything else for the time being, at least? What happens is that a roadmap emerges naturally. What is a roadmap? It's a collection, a sequence really, of sets of tasks that we have to work off in order to enable working on the following tasks. And I hope none of this is new. I think it's called the critical path method. And I'm not even qualified to talk about project management or anything here. What I want to say is, I think we should have something like this for the documentation project for each of these areas that we've been talking about. And in fact, I think we should have something like this for all of the Nix communities, simply for everyone to know at any point in time what to work on next, even if you just arrived. And most of the time that I've been spending is essentially figuring these things out. And that we can break that down to a couple of minutes. I hope that may be a way to finally get on top of things. Just to remind you, I think everyone in the room knows this, but maybe not everyone on the internet. There's something like 10,000 open issues or pull requests on Nix packages or in Nix. That's way too many. Even if you boil that down just to red boxes, to these leaf nodes of the dependency graph, it still remains tons of work. Who's going to do this? Well, think about it. What's the characteristic of open source, community-driven software projects like ours? What do they all have in common? Participation. Changing them is a core feature. That's what we can do with all of them. It's a first-class use case, and I think we should treat it as such. And that is what I think the documentation team should work on next. Make the process of contributing to the Nix ecosystem the most welcoming, smooth, effective, and rewarding out there. And everything else will come. Still, we cannot do this alone. We've seen the tens of thousands of pull requests. This thing is so much bigger by now than any single one of us or any small group of people. So we need your help. But who is you? So of course, all of you in the room, you're already working on Nix, it seems. But we still have to continue to rely on volunteer contributors, on these people's passion and energy. And we know for a fact there's many, many people who will gladly offer an hour here and there, or even more, much more, to help the project succeed. And so now I'm talking to you, everyone. If you want to improve Nix, help improve documentation. Search on the internet how to contribute to Nix documentation. You will surely find the little overview we've prepared already a couple of weeks ago, with a collection of small, ongoing, but always self-contained tasks that anyone can pick up immediately and then go off and help make the world a better place, one pull request at a time. And I mean, that's why I think we should work on this next, improving this contributing workflow, because we simply cannot afford to waste people's time if they want to help out. And at this point, I would usually say, okay, thanks for your attention, and head off for the buffet or whatever. But it's not that simple, unfortunately, because it doesn't end here. Let's think about these 10,000 issues and pull requests. So at best, if I succeed today, asking for help, people will flock to GitHub and open new issues and make pull requests and all that stuff. We'll just have 10,000 more of them. It doesn't help. At this scale, doing this one pull request at a time thing, it doesn't cut it anymore. We absolutely need some coordination, and for that, we need maintainers. People who know the thing in and out, people who know what to do next, people who are really quick at assessing whether a contribution is worthwhile to even pursue. And the problem is, of these 500 people who contributed only in the last month, most of the changes they did are only about code. Okay, I'll tell a little story now. In the past months, I've been talking to lots of people, and at some point I lost track how often I've been told, it's so great that you're doing this, awesome, thank you very much, finally. Because people hate writing documentation, people rather write code. You know, something that does things, something that works. And only recently I stopped wondering what the hell must be wrong with me, because I actually find this fun and rewarding. And so, like 3 weeks ago, staring at the blank screen, trying to figure out what I will talk about today, it suddenly struck me. Of course people like to write code, because software and code solves people's problems. But so does documentation. It does things in people's minds. It also solves problems, very immediate problems, people's problems with the software and the code. So what's the difference even? I mean, after all, it's all just character strings typed into a computer. What if we treated documentation more like code? What if we develop documentation more like we develop code? Because for all intents and purposes, documentation is code. And why don't we just apply all the software engineering best practices that we know and love, but to documentation? Basic, simple things that anyone who's into computers and also in their right mind would never live without, such as version control. Of course, documentation should be under version control, but take a wiki, for example. It only has version history. And if you know what a Wikipedia edit war is, I don't think that you would want to develop your code that way. Separation of concerns. We already talked about the user-oriented framework. Every piece of code should serve one purpose, so should documentation. Single source of truth, it's quite obvious. Keeping it simple, not trying to be clever, not trying to be funny. It just distracts people. Data types, that's maybe not that obvious. I mean, data types help with readability and refactoring of code, but that also applies to documentation. It's also simple things such as, if you have a collection of things to talk about, don't inline them in a paragraph, use a list instead, or maybe a numbered list, or maybe even a definition list, depending on context. Tests, of course, you write tests before making a pull request, and you run them also before making a pull request. Why don't we do the same with documentation? And this is about like running tests on the examples such that they are correct. Run tests on the actual documentation, whether it works. How do you run a test on documentation? Well, you run it on users. You check whether it actually works for them. Code readability. I mean, of course, we read documentation, and we also care a lot about readable code and programming. We even have flame wars around formatting, and not all of the reasons for those are stupid. But documentation is no different. We even have a dedicated programming language. I'd call it Markdown English or something. We even compile it to HTML. So we can have lots of fun with this analogy. We can even throw in dependency management for good measure, like prerequisite knowledge and references to external definitions as built inputs and runtime inputs. So anyway, I can have another talk just on this. My favorite is, of course, documentation. We have to tell people how to work with documentation and to unwind that stack. That all ties into helping people contribute to a whole project. And it starts, I think, with documentation. Okay, if you're a software developer and you still find documentation boring, just imagine writing documentation is something like programming people in Markdown English. But we need even more maintainers. We need people who can focus on one thing and do it well. Otherwise, simply nothing will happen. There are just too many rabbit holes to fall into. And I think there's lots of untapped potential still for great maintainers outside the audience of software developers. Because the tasks involved in these areas are very different. So of course, working on reference documentation is a very technical task. You have to be intimately familiar with the code. You also have to write lots of code to make it work. But guides are more, I mean, in lack of a better term, like marketing. You have to know the product really well to kind of map out the use cases and describe them to people nicely, and it's less about code. Tutorials are essentially teaching, and explanations involve lots of storytelling. And while all of that requires some technical expertise at the least, they're all dedicated skill sets that people go to university or work for many years to get good at them. So we need these people, not just to improve documentation substantially, but as a community to become better with what we do. So I say this now to everyone who believes in the ideas behind Nix, but doesn't want to go into the code too deeply yet. Please consider becoming a maintainer. Please consider taking ownership of some part of documentation and help this rapidly growing community does what it sets out to do. To quote Elko, take over the world. You can make a huge impact. But we need good writers, to improve the use of language and to tell better stories. We need teachers to help people all over the world learn non-trivial skills. We need designers, not just for illustrations and diagrams, but to become better at visual communication as a whole. Even MBAs. I mean, please help us with project planning. Please help us keeping focus. We need all of you people, and we can learn a lot from all of you. And in turn, if you're open-minded, I think you'll also learn a lot from the technical domain, things that you can use otherwise and elsewhere. So if you're interested, please get in touch with the documentation team, and we can see how to get you onboarded. So we've talked about coordinating the effort with maintainers, but to keep that effort going, someone has to commit considerable time to do all this boring, annoying, hard things that volunteers simply won't do, because volunteer work has limits. Most people don't have the privilege to work for free for a long time. They have to be paid, so we have to talk about money. If we want to find and keep good people that can take care of these things that we as a community care about and to actually improve on them, we have to pay them. So I'm a living example of how that may work. Like 3 years ago, I started making small contributions, and now working on Nix is my day job. And again, I thank Tweak for making this possible. It's amazing. But I'll probably have to step down from leading the documentation team next week because my funding is running out. And that's natural. It's not about Tweak or me or anyone really. And I don't care who does the job eventually, as long as it gets done. I mean, I'll gladly hand over to anyone who's willing and actually able to afford to step up and take the responsibility. But what I do care about is, how do we keep up this momentum that we've been building? Because I hope from what I've been telling, you also see that we have just begun. So I say this to people in charge. We have representatives of various companies here at the NixCon, and I hope the internet is also listening. Look, the Nix community, it needs trusted, what I would call custodians, reliable partners who can help us provide the resources to maintain and grow our collective assets. And this is not just the code, it's mostly the people. People like Elke Dolstra, Stefan Hufschmidt, Selma Mosberger, Robert Hensing, all the great people that I had the pleasure to work with in the past months, just to name a few. And if your organization relies on Nix thriving and being alive, if your developers would benefit from better documentation, if your hires would benefit from a smoother onboarding process, please consider helping to continue what the Nix documentation team has begun by providing us the resources that we need to work effectively. And I emphasize, in the long run. Because, okay, there's many ways to help us. Money's good. In-kind donations are also fine. Yes, indeed, please send your experts. Help us with becoming better of what we do, where we are not good at yet. And for donations, of course, the prime address is the NixOS Foundation. All the board members are here today, and I suppose tomorrow too. If you're interested specifically in documentation, please talk to me. But I think this concerns all the Nix teams, all the people that actually want to do something substantial about Nix. And I emphasize again, what's really important is sustainability. I'm convinced that Nix is an investment in the future of all of software development. And many people here have been at it for a long time now, trying to make good on that promise, to make that dream come true. And documentation is only a tiny part of that. So for that investment to pay off big time, and I think it can, we still have a very long way to go. And I hope that I could convince you today that we need everyone's support. It doesn't work without the other. We need engaged volunteers. We need passionate maintainers, and we need those custodians. Custodians that we can rely on to provide the necessary resources to get the work done. So we have a plan. We know what to do next, at least roughly. We have many ideas how to actually get things done. So please, let us get together and make that happen. So if you want to get in touch, here's my contact details. Thank you very much.
Give me a second. Yes, so am I. So I'm sure there's hard questions, and there's enough of them. Okay, Domin.
Thanks. Yeah, thanks for a great talk. What I can offer is, with Native, we've been organizing an ocean sprint for 2 times, and there's another one coming in November, and most likely another one in March. So if you're looking to escape, hard winter in Europe and US and come to Canary Islands and write documentation for 1 week, we can make it a theme. And all you need is approval from your employer to come. And of course, Valentin, you're welcome to join and help us make it happen. We've been working on documentation as part of that sprint as well. So hopefully that leads us a bit closer to the goal. And again, thanks for your talk.
Thank you very much.
You talked about software engineering principles, and as a software engineer, one of my favorite things to do is deleting code. So I'm wondering if you have any thoughts on deleting documentation, because I think it's often easier to add a little something and it balloons, maybe not in official sources, but everywhere, right? And people just Google stuff and then they find things that are outdated by years and years, and nobody knows, because nobody feels that they have the authority to change anything. I'm wondering what your thoughts are on that.
That's a good point. So in principle, it's already hard to write concise documentation, and I think it's the same problem for code, trying to find a minimal solution for a problem. Yes, deleting is good if the stuff is outdated or wrong, and this is what's part of this overview for occasional contributors. Let's try to make the NixOS wiki smaller, because it doesn't offer version control. I wouldn't say, as Rock said, 2015, to kill the wiki. Let it die slowly. Let's kind of let it evaporate and merge the good stuff into the curated version control documentation and let the other stuff disappear. Deleting other stuff, which is not under our control, is a lot harder. For that, we need, well, something that we probably won't get, like large community buy-in, where people posted tons of blog posts about things that are way outdated, which simply like either are not best practices or don't work anymore. That's a lot harder. But if we provide authoritative documentation where people don't have to look on the internet for all kinds of things, maybe that's not so much a problem. So I think right now we're in the process of, we have to grow documentation. Right now it's not enough. Some of it's wrong. If you find something that's wrong, just delete it. On the NixOS wiki, just throw it away.
Do you have any opinion on like when fixing problems live for someone in a chat versus having something more long-lived on discourse or a Stack Exchange type of thing? Like, are we just wasting a lot of time fixing problems when they pop up? Could we have something more long-lived or at least searchable?
That's a great question. I do have an opinion. I have lots of opinions. Most of them are probably wrong. But yes, I would love if we adopted what's so far called the Boy Scout rule. We should find a better name for this. So whenever you find a problem, it would be great if instead of just fixing one person's problem in the chat, as you say, or in person when you like hack on Nix with friends, so before you do anything, you make a pull request to the official documentation. It will probably get stalled until we have enough maintainers to actually take care of this. But that would be way, way better. And I know this is a lot of work that also stalls your process. You want to show something about Nix, you want to show to your friends. Oh, wait, it doesn't work. Let's first make a pull request. Oh, how do you do that again? So this is why we want to work on contributing first. It should be straightforward to fix a typo. It should be straightforward to fix a fact. And then, please, yes, do that. Like, don't let that sink into this information black hole that Matrix is. At the very least, and there's actually in this contributor guideline, there's an overview where to put information. This course is a good first step because nobody has to like look at it. The NixOS wiki, well, sometimes it's worthwhile still to improve the existing material, but even better, just put it into the reference manuals if possible. Put it on nix.dev if it's a tutorial or guide or you want to fix something about it. Do that. Look at the overview, how to contribute to Nix documentation.
Hey, Valentin. I'll ask one question two ways, and you can pick which way is more important to answer. Now that the Nix language tutorial has been merged, what's the next big choke point to work on? Or what were in those red leaf nodes that you had up on the slide?
There's a bunch of things. We're still working this out in the documentation team. And I think, so actually, what to work on next, I think I said. Making the contributing workflow better. We still have to take care of like the influx of issues and pull requests that will probably arise from this. But the leaf node in the dependency tree is probably some tool that would allow us to create those graphs in the first place. Because GitHub doesn't have a feature to display dependencies between issues and pull requests. I mean, not issues and an individual pull request, but issues and other issues. So we can express this by just writing a link to another issue, but we have no way of querying this systematically and producing these nice little graphs. If someone built a tool which does just that, I think that would help a lot of people. So if anyone wants to sit down and do that, please do that. For reference documentation, currently something obvious, which you can actually see from this graph if you could read it, is rendering reference documentation from source code comments. There are a few people interested in doing this. If you look for this, maybe you can find them and work together. That would be a really worthwhile goal because it would get us closer to this everything is a single source of truth and correct.
Yeah, nice work. It's looking cool. Documentation is a problem. But do you know where the most up-to-date documentation for Nix is?
Sorry, I didn't get the question.
Do you know where the most up-to-date documentation for Nix resides?
Well, it does reside in the manual for Nix and Nix packages and NixOS, and also on nix.dev, and I hope that is where it should go.
No, it's not any of those places.
Come again?
It's not any of those places. It's the integration tests. I've solved so many problems by looking at tests, yeah, because that is documentation for me. Not English words, code as tests. You talk about testing the documentation, but the integration tests are the documentation. Do you understand? So every time we need to check something in, a feature, it needs an integration test, even if it's very, very simple, because they're educational tests. Do you get what I'm saying?
Yeah, of course. I think those tests, if they're written well, should be part of the documentation that people can actually read for examples how to use the code. And they should be tested as part of integration, of course. But it's quite a far-fetched goal. I mean, we're just at the very beginning. There's a lot of technical stuff involved, and someone has to do this, right? And there's lots of stuff to do. Yeah, I agree. It's a worthwhile goal. It's definitely a worthwhile goal to pursue. The question is what to start with next. I agree. It's a worthwhile goal to pursue.
Don't worry, you can have a conversation. So Valentin, I got another question for you. What do you think the place of Stack Overflow in all this is? Because one of the things I teach my students is Google your question. And one of the top things Google gives me in most of the programming or anything about it is most of the time Stack Overflow answer. So do you think, what do you think the place is here?
It's a kind of a sensitive question. So I don't have really an opinion on this because it's sort of in the realm of community management. It's kind of at this intersection point. So what if we crowdsource this how-to documentation, right? And Stack Overflow is just one tool to do that. There's multiple options to do that. To be honest, I don't know. I haven't thought about it too deeply because I think we have other concerns right now. But it's a worthwhile question to pursue. Please feel free to discuss this on this. On GitHub, on Discourse, there's a recent thread where someone talked about this.
Give it up one more time for Valentin, please. Maybe a standing ovation, right?
You gotta use standing ovation.
All right, we're gonna do, if everybody can sit down, promise you guys, this is the last 8 minutes of talks. 7.5, don't take my word from it. If folks can sit down, we're gonna do like the closing ceremony. We're gonna do a
Could
few last
everybody
things.
sit down, please? Just a few more minutes. Come on, guys, we can do it.
1, 2.
All right. So we're going to start concluding the festivities of the last 2 days because NixCon never ends, and technically we have a hackathon tomorrow. But first thing, before we actually release everyone fully, we really need you to take out the phones and do the survey.
Right now.
Thank you. I'll go aside.
We're waiting for you.
Can we also send it on the NixCon matrix, please? Oh, it is also on NixCon? No, the matrix channel. Yes, please. to the chat, to the matrix. No, I can't.
It's on its way.
You can come if you want to scan the QR code.
No, I'm sure someone from the front row can put it on matrix, right? Okay, thank you. In general, it's really just a few small questions because, again, we really want to get you while you're fresh. You just finished it. The things you hated, the things you loved. One of the more interesting bits to it is about where the next NixCon is. So I would love to get that feedback, right? There are places that are cheaper than Paris. There are places with a beach. That's only my personal preference. But we would really appreciate everyone just take 5 minutes and then we'll continue from there.
We're doing do not disturb like really quickly. Yeah, it's.
Okay, Alexandra said that I was not inclusive, so I'm now going to stare directly into the camera and ask everyone that is watching NixCon. You heard me, okay.
Please know that we are very, very sad that this moment is going to be ending. Like, has been very emotional, very intensive for us, and we have been seeing all the mingling, all the feelings of the people, everyone enjoying the conference, and we are really, really happy to have done this with you, and also with you.
We're going to just shut up for 5 minutes because we.
People who have finished the survey, can you put your hands up? Let's wait 1 more minute and then we will tell you the rest.
Can you send like an email with the survey link like afterwards? I think it's much better to fill out afterwards.
Yeah. We'll definitely be sending it also after. It's just sometimes it's useful just when it's fresh for some folks.
I mean, you can fill it twice if you want. It's not a big deal.
All right, let's go.
So we have multiple public service announcements. First of all, there are some food and drinks left from the lunch and for the conference. So you will be able to take some food from the fridge if you want, some vegan, maybe I think meat menu. The desserts were excellent. I think the cold meal is not very good. So choose whatever. For the drinks, you will be able to take one for home until we think we should keep more for the hackathon. But please come to the drink station and ask for some bottles if you want. We also have some t-shirts, mugs that were not taken. If you want more t-shirts, or if you want your t-shirt, or if you want more mugs or your mugs, don't hesitate to take them. For the hackathon tomorrow, it's going to start around 9 a.m., 10 a.m. This is a self-organizing event, so basically you can drop by and coordinate with your team with the subject you're interested in. And basically it can last around 6 p.m., I think, and more if we find some room for that at ENS, and I think we were able to do that. There will be internet, I hope, should be. And I think that's pretty much it for the hackathon.
Yeah. Will there be...
For food, we are planning to use maybe food from the fridge and maybe pizza, but don't maybe plan something for food. We're not guaranteeing a meal.
Cool. A few more things that we just wanted to mention on the board side. Again, I don't know how much traction or people have seen this. We've also, a few months ago, we started posting the meeting minutes. And we also have a good issue where you can just submit issues, track them, add comments. So just wanted to mention that. From there, we would love to actually start concluding the event officially. And first of all, we wanted to call out every single one of the organizers that really made this happen. I can't even emphasize, and I'm going to pick on some of our Parisian friends here. This is a gym. This looked like a gym 3 days ago, okay? So the tent, the micro, the deep dive into making sure that every one of your needs are kind of fulfilled, to me is insane. So I want to first bring everyone up here. They really deserve all the thanks and all the credit that we can give them. Alexandra, the person who organized it from the US side of the world.
The ENS team, Julian Malka, Gabriel Doria-Dollar, Maurice Debray, Tom Ubrecht, please stand up.
And a few more folks that we're going to force to come up here. I'm saving Brian for last. He obviously, deserves all the. He deserves the biggest.
Just in case there is a sound problem.
I want to call Jonas up here. I want to call Rock up here. I'm going to look you guys. Where are they? Where's Jonas and Rock? Did we lose Jonas and Rock?
Someone grab Jonas and run.
Jonas.
In the meantime, I forgot something for the hackathon. The entrance will change. It won't be here. It will be at the official entrance of ENS. So we will put it on the matrix. But if you come here, I'm going to fetch you anyway. So it's fine. But please.
Here's Rock. Nick is not here. Nick.
I don't think so.
All right. There's
Nick is here.
Yes. I hope Nick is watching this. I think you guys all know him as N. Batum. I hope I'm pronouncing that right, but he was a big part in organizing this as well. A few folks that are not.
Matthias, come also. HD, Matthias, HD, come here. We didn't forget you.
We also had a lot of help from Jacqueline, who's not here with us today, but I want to say thank you to her. CTEM as well. And now, last, of course, but not least, I want to just get Brian on the stage, all right? Now, I know that you have seen some people, but like, this is only the top of the surface of people that took part in making NixCon happen. You've probably seen some like sounds in the back or things over there. They've been not sleeping, having anxiety, and probably just like freaking out completely. I'm hoping that tonight they'll get a good night's rest. They deserve it. But really, everyone here made this happen. And I do want to also call out Ryan. So again, you saw my presentation, but I'm gonna just mention this again. Ryan, in a conversation, it was like, Ryan, he goes to me, it's going to rain. I'm like, oh, okay, what do we do about lunch? And Ryan's like, oh, I got a tent. And then Ryan's like, I also got flooring. No way in hell that I would have like thought about getting you guys flooring. We would all have been like mud up until here, a bit of a joke, it would have been nice, but like this is the guy. All right, so again, these are all the people running behind the scenes that made this happen, but honestly, all of our volunteers, all of you, I mean, this is the community, right? So I want to kind of like, you guys deserve it as well. Thank you for coming. Thank you for being part of this. Thank you for picking up and dealing with all the messes that we've made. This is kind of what Nix is about. So thank you guys as well.
At first, we wanted to call all the volunteers, but you are all the volunteers. So we're not going to do that. But I want to say thank you to all of you. Thank you.
So we gave Valentin a standing ovation, and you guys have been clapping a lot, but some of you actually said like, oh, you're doing a great job. With none of these people, I would have been a wreck. I would have been laying on the floor by now, dead, right? So please give them one more round, like a huge round of applause. Just yell, just scream. Let's go above 100 decibels, please. Please say thank you for making all of this happen to the people that made it happen.
All right. All right, last few things. Thank you guys, that was awesome. No, you guys should stay. You guys actually stay. I need you here.
So for a bit.
We need you here. So last few things. One, at the end of this, at the conclusion of it, this is also all thanks to the sponsors that you see behind us right here. So again, I do want to mention every single sponsor that funded this, allowed us to give you these awesome drinks and swag and seats and stages and all of Ryan's crazy dreams. Antithesis, Cashix, it's weird to say Flux, Ryan and the ENS, Google, Twig, Numtide, Seroquel, Determinate Systems, Obsidian Systems, Mercury, NixBuild.net, Hercules CI, Meatwise, PDT Partners, WorldQuant, Flying Circus, and of course, NixHow. I hope I didn't miss anyone? No? Okay. So they're all here. They're all here in the back. They're hiring, right? So I want you guys to, once you get up, talk to each other, have fun. If people are looking for work, look for folks with like green dots on their badge. They're actively hiring Nix people. Crazy. So that's the hiring happy hour that's going to happen in just a minute. So don't leave before you do that. The other quick thing that we wanted to do.
So we have some final COVID-19 instruction for you. We have a lot of masks, and you're all going on a journey. Whatever you will be at the hackathon tomorrow, or you'll be in your plane, or in your train, or whatever, please take some more masks with you. We have plenty of them. Also, if you are sick in the next day, I hope you're not, and I wish you're not, but don't hesitate to tell us that you are sick, and we can figure out something, and we can like ping people and be responsible about that. Finally, I'm trying to find my words. We're going to have a need for a lot of help for the tear down, to break down everything, to make this gym, a gym again, maybe, or to pass it to the next people. I'm going to need like 20 volunteers who are going to see Gabriel here. Don't fly. Gabriel here, who is going to supervise taking the chairs out, putting them back in the stuff, etc. We're going to need some help also with the tables that you use for lunch. We're going to need help for drinks. So Julian here is going to supervise drinks. I'm completely improvising this, just you know. No, I can't use you guys. And that will be pretty much it.
So last thing, he said we're improvising this. We started organizing this like 4 months ago. This whole thing is an improvisation. We want to do a group photo. So if anybody cares for it, we'd appreciate if you come up like close to the stage here and look that way. Yes, or that way, which Alexandra is the photographer. I have no clue what I'm doing. Okay, so look that way. So come to the stage, look that way. If you can somehow organize by height or kind of figure out how not to block others, that would be great. But like, let's come on stage, let's do a group next photo.
And a last piece of news, like a bit of a teaser. With Brian, we have been looking into doing a Nix dev room at FOSDEM. So it's true, NixCon never really ends.
Where is Ilko? Ilko, can you raise your hand? Oh, Ilko. There's Ilko. Ilko, can you lie down at the front? I don't know. You want to come up stage?
How many engineers does it take to take a picture?
We'll do a few normal ones and then just like go crazy. I don't know. Do Nix things while you're taking pictures.
Make a reproducible photo, please.
That was an Alexandra joke. By the way, guys, Alexandra's like starting to get into Nix jokes. So I'm proud of her.
We want to live.
It's not reproducible.
Oh no, we need to do a funny one. What are we doing? I don't know. Nix things. Nix things. Do something Nix. Like they should do one. Oh yeah, we do the letter. We do the letter. Oh god, no, How about like just don't smile. No one's.
This is for investors.
Serious look, guys. We're all serious business. Thank you all.
Thank you a lot.
Thank you. Have a good day.
So please don't forget about 20 volunteers, seeing Gabriel and Julian for helping. Thank you very much for that.
And hiring happy hours in the back. Please go mingle, drink, have fun. Yeah, all the gold sponsors that are hiring, if you can see Alexandra at the back, that would be great. Thank you.